Let us start now. Night sir, shall we start? Welcome all delegates. Today's in today's event schedule, our first, this is third session, will be on design norms in respect of intermittent water supply and continuous water supply. So I request uh, moderator for this session, Dr. Pradeep Kalwar, to come on dais. And today's speakers, Colonel Bhaskar Tatvavadi, Engineer Sandeepan Chaudhary, and Dr. Ullas Naik. Please come on the dais.
ಇದು 30 ಸೆಕೆಂಡ್
Yes.
ಬಫರಿಂಗ್ ಬೇಡ
Good morning. So today we'll start this session. Yesterday we had very nice sessions on variety of topics covering different modes of water supply, social aspects, smart metering, infrastructural requirements for continuous mode of water supply, and very nice panel discussion about whether there is a need and feasibility of 24/7 water supply. So today we'll go a little bit deeper in this particular session on design aspects in respect to intermittent water supply and continuous water supply, and we have very nice experienced panel members who have worked in various in this sector in different positions. So first we have our first speaker, Colonel Bhaskar Tatvavadi, and it is my pleasure to introduce him. He is an army veteran and a civil engineer from VNIT Nagpur with master's degree in environmental engineering from IIT Roorkee, and he has over 49 years of professional experience, more than my age, and that's really great. His 22 years stint in the Army Corps of Engineers included construction of water treatment plants, design of several sewerage systems. His main expertise is wastewater reclamation. He specializes in technology and process evaluation. He has recently taken over as the chair of the Water Reuse Task Committee of EWRI, American Society of Civil Engineers. So we have such a very long experienced and expert person with us. So I request Colonel Tatvavadi to start his presentation, and if other speakers want to just shift here, that is fine, so that you can see the presentation.
ಲೈಟ್ಸ್ ಆಫ್ ಲೈಟ್ಸ್ ಆಫ್ एलईडी का बैटरी लगा चार्ज बैटरी लगा एलईडी का बैटरी लगा हाँ? चलेगा वो तो बाद में कर सकते हैं हाँ मैं कल भी वही बोल रहा था उनको हम ही है बोलूँगा ओके
Hello. Good morning, ladies and gentlemen. Chairperson of Indian Water Works Association, my Manisha Palani madam, other officials of the Indian Water Works Association, ladies and gentlemen. I thank the Indian Water Works Association for giving me this opportunity to share my sentiments on the need and feasibility to revise the existing water supply design norms. I will be talking about the context of this need and feasibility. Talk about the urban and rural water supply. Review of the discussions which were held yesterday. There were very prominent speakers and experienced engineers talking about the various facets of the CMS and the IMS mode. There are some policy integration issues and the rationales which we are talking about in this seminar, the rationality of those rationales. Also, my personal opinion about going about the entire process of conversion from IMS to CMS, SMART and PDCA as the basis for this conversion. A little historical perspective on the water supply in our country is that our urban water supply dates back to early 20th century, 1908, 1910. I don't want to go into the dates and historical perspective, but that is when the water supply started, and it was primarily for the British rulers, their troops and their garrisons in the country, and the urban elite of that period. Later, the middle of the century and the independence struggle saw the water supply extended to many other towns and cities in some form or the other. The norms of supply were ad hoc depending on the availability and source, and were not fixed in any manner, but the British garrisons had their own supply norms. The rationalization of the entire water supply sector, it started post-independence. Now I come to the contemporary norms. Most of us were born in independent Bharat, and working in water sector, we have benefited from the standards and manuals drafted in the last 5 decades. These decades have seen unbelievable transformation in science, technology, engineering and mathematics, and of late in artificial intelligence and machine learning. So we have seen the entire range of evolution of technology, and therefore today we have the benefit of our experience with basic mathematics as well as the latest technical innovations of AI and ML. So I feel that the water utilities also must align their operations and take advantage of the technical innovations which we have. Okay. One of the most important things we must remember while talking about water sector is the fact that the water availability, the gross water availability in the country has reduced from over 5,200 cubic meters or kiloliters per capita as it was in 1951 to slightly below 1,200 cubic meters or kiloliters per capita in 2021. That is why there is a need to review and redraft the design norms, because even as the population is increasing, the source and the availability water is decreasing all around. And this is a global phenomena. I'm not going to talk about climate change, but I'm definitely concerned about the sustainability of supply. So this is that graph which shows the reduction in per capita water availability. And if we as water sector engineers are not concerned about the direction of this graph, then I think we are wasting our time. Okay. I come to the urban and rural water supply. We have the Jal Shakti Ministry, which oversees the Clean Ganga Mission among others, and the Har Ghar Jal Mission for rural sector primarily. We also have the Ministry of Housing and Urban Affairs, which deals with urban water supply through the Central Public Health and Environmental Engineering Organization, the CPHEEO, which is vested with the responsibility of dealing with urban water supply, and also to devise the norms and for the urban water supply. And surprise, these two seem to be completely de-linked from each other, because it seems that the engineers are only concerned about the urban water supply without any reference to the rural water supply, where the 60% population is rural, 40% urban, and the water resources are divided exactly in the opposite manner. 60 to 70% water resources are earmarked for the urban sector and 30 to 40% for the rural sector. So there is some elitist sentiment working here among the water engineers. This CMS over IMS, which is debated here, must also equally apply to the rural sector, don't you think? We are not the privileged ones who should have a continuous mode of supply, and our other brethren, my brother who lives in a village, he should be able to make do with those 55 liters which is earmarked for him, which he may get once in 2 days. So my appeal to the enlightened audience here, please consider the need to apply any change in design norms to the rural sector as well. Yesterday we had enlightened discussions and presentations from the veterans of the water sector. Professor Pradeep Kalbar, he concluded that water supply is a wicked problem. In addition to being an extremely wicked problem, it is also a very complex problem. Dr. Pawan, he argued that CWS has a lower contamination risk than IWS. I presume there is an age difference between the networks of the CWS, which would be relatively new, and the IWS, which would be relatively old, in fact much older, which is why this difference persists. My request is, if we want to compare, we should compare apple to apple. If my IWS system is 10 years old and CWS system is laid last year, I cannot compare the two. The sample size which was mentioned in the presentation was too small to be applied to the whole country, which is what I feel is being done in the other case study which was presented by Dr. Gupta also. Here also, the case study was location specific with a very small size sample, and therefore I feel that more such studies need to be done to reinforce their contention. I come to the presentation of Mr. Dilip Sonone. He spoke about the gradual evolution of increasing water supply to the city, including gradual increase in the nodal pressure over the city. And that I feel is a very, very reasonable approach when we are dealing with improvements in water supply. The PCMC presented a pilot study over a small area of 0.4 hectares. Good first effort. The results are encouraging. whether those results will replicate in the rest of the city, which has a very what should I say, complex topography, remains to be seen. Dr. Ravindra's study showed that random pipe sizes were used. For instance, he said 350 mm and 100 mm pipe sizes, minimum pipe sizes. If we do the design as per the design norms suggested for the CMS with a peak factor of 2.5, then these pipe sizes would be too large to accommodate the flow, which means the water flowing through the pipes in quantity is much more than what it is to be designed for using the 2.5 peak factor. So, in short, I do believe that these studies have been seriously conducted, but the rationale to give these studies in support of shifting from IWS to CWS or IMS to CMS, I am slightly confused whether these are the right case studies or not. Now, another grouse which I have is that we are all the time talking about supply. Our manual is water supply and treatment. We talk about water supply projects. Why don't we talk about the demand? Are we blind to the demand or demand management? Why can't we look to the other side across the table as to what is happening to demand and how can we manage the water demand? I have not seen any guidelines or any discussions on the demand side management. How can we reduce the demand? How can we optimize the demand? We are very happy to have water supply augmentation projects. I have not seen any except for mentioning some reduction in losses, which is also a perfunctory or a traditional paragraph to be inserted in any report saying that we conducted studies on leak detection and we have been able to reduce leakage by 0.1% or 2%. I have not seen a focus on demand management. So we are not bothered to restrict the flow beyond the just demand of a DMA. I have not seen anywhere this happening. This is my supply side quiz. If population is 4 lakhs, 150 liters per capita per day, 60 MLD supply for a city. If I divide by 24 hours, then my flow comes to 2.5 million liters per hour. But my CMS guideline says that I should have a peak factor of 2.5. Multiply by 2.5, I get a flow of 6.25 million liters. Then, if I have say 4 hours of peak supply out of 24, in 4 hours I consume some 26 million liters and I am left with 60 minus 26 equal to 34 million liters to be supplied in 20 hours. If I supply in 20 hours, then my peak factor reduces to 0.68 for those 20 hours. So what is happening to my 2.5 peak factor? My arithmetic tells me that when this peak factor goes down to 0.68, some of the pipes are empty or they are not flowing full. And if they are not flowing full, the entire argument of keeping pressurized pipes over 24 hours to reduce the contamination falls flat. NRW reduction myth. Another myth of NRW reduction is that marginal percentage reduction in numerical terms will actually result in savings. This is not true. it will actually result in much more wastage, because supply of 24 hours is 800% to 400% more than the 3 to 4 hour supply of intermittent mode. Okay, more wastage also happens due to leakages as the supply head is increased from the existing 12 to 21 meters. It is a multiplication factor of 1.75 or 175%. Even more damaging is the arbitrary choice of larger pipe sizes than those which are designed using this peak factor of 2.5. So if I get a pipe size of say 50 millimeter diameter, and instead the manual prescribes a 100 millimeter diameter as the minimum pipe size, I am wasting 4 times more water in that line. This is, you may kindly check this mathematically and prove me wrong. I have got a few questions and a few answers. Is it feasible to revise the existing design norms? Answer is yes. Necessary for urban and rural sectors both? Yes. Should the revision be gradual as smart? Smart as in our ISO norms, and follow the PDCA. Plan, design, check, act cycle? Yes, it should be done. Is the old manual design norm for IMS? Gentlemen, ladies and gentlemen, the old manual was not designed for IMS. It doesn't say IMS or CMS. It only gives the design norms. What peak factor has been used in nearly 80% of the existing networks is 2.5. You may please check. Is there a need to redesign these networks? No, because they already have a peak factor of 2.5. And do we have 24/7 power supply? The billion-dollar question for any water utility. And if we don't have this, how are we going to have CMS? May kindly be explained to me by those who are professing this. Few more questions. Do we monitor the demand fluctuation in real time anywhere in the country? No. Do we actually estimate the UFW, NRW on a daily basis? No. Do we stop supply when the quantity per scale is supplied to a DMA? No. Do we even think about these things? Do the ULBs have the trained engineers, technicians to perform the due diligence with regard to the quantity supplied every day? No. Do the ULBs have trained engineers or technicians to perform due diligence with regard to the quality of water supplied? No, not at all. Nobody talks about the quality. Do the ULBs assess network conditions periodically by themselves? No, unless it is part of a new scheme. Are the water consumers even aware of the cost of water production, the elephant in the room? Nobody knows in Mumbai what it costs to produce a kiloliter of water. It is supplied by the MCGM at 6 rupees per kiloliter. I think the cost is about 25 rupees, close to 25 rupees per kiloliter. Do we even attempt to enlighten the general public or the consumers about the actual cost of water? And then if we start talking about the cost of water, this whole discussion about the CMS and IMS will be thrown out of the window. Do the ULBs have a program to claim wastewater for reuse? And this wastewater reuse is the second most important part of the policy of water management when we talk about SDG 6. There is no discussion to reclaim wastewater. Yesterday, a very senior engineer, Mr. Mathur of Rajasthan, was present. I don't see him here today. He spoke about Rajasthan as being the state where 24/7 water supply is being introduced. I was shocked that I have not seen any reference of Rajasthan in any discussion about the 24/7 or the CMS water supply. In fact, I may mention here that Rajasthan was the first state to bring out a policy about treated wastewater reuse in 2016. The second was Maharashtra for reuse in industries and the thermal power plants. The third one was Gujarat. Gujarat has come up with a policy which also talked about direct potable reuse. And these are policies to make your water supply, our water supply sustainable. But unfortunately, the manual, the draft manual only talks about these in passing as if this is an unimportant aspect, and we have all the water in the world available to us, and therefore we can merrily go about designing schemes for continuous mode water supply. Unfortunately, that is not the case. Is it necessary to rethink the urban water cycle? I have drawn here I will show a modified urban water cycle. At the left hand we have a source. Water comes to the consumers, it is used. Red is the wastewater. Wastewater flows to the wastewater treatment plant. Becomes after treatment, part of it is reclaimed at least, and then it is brought again into the stream of water for reuse, and therefore the source only gives the makeup water. So this kind of urban water cycle we have to think about, and think very, very seriously about water reuse. Okay, to meet the demand, if we consider a zone of say 20,000 population at 150 LPCD and install smart meters at the consumer end and start supply at any time at any variable rate, as soon as the meter records 3 million liters, which is as per the scale for that population size, we must stop and lock the supply. This is possible today because we have the meters and we have the valves, and this can be interlinked and the supply can be stopped. This is precisely what I mean by demand management. You as water engineers are not bound to supply even a drop more than what the scale prescribes. Yeah, the biggest room in this world is the room for improvement. A wise man had said. So yes, water management is not an exception, and ULBs must ensure that the locations of supply, there was some discussion yesterday on decentralization of supply, and this is what I am talking about, that the supply locations, the spaces must be earmarked for the utilities, and decentralized supply is a must. Yeah, this draft manual 2023 is under publication. As a water engineer, when I saw, I had some reservations about it. I documented my reservations and I submitted I have published my reservations in a LinkedIn post. After that, there was another draft with parts A, B and C, and on that draft also I have mentioned my reservations. The LinkedIn post is mentioned in this slide. The CPHEO then conducted a video conference to sort of tell us that we are trying to take the country backwards to the 20th century. My worry is that when the rest of the world, including India, is today trying to restrict supply, we cannot be immune to the problem of dwindling source and increasing supply. When I was very young, my mother used to tell a story. 4 learned friends were walking through a jungle. They see a carcass of a dead animal. One of the wise men, he identifies it as a dead lion. The second one, he chants a mantra, and the bare bones become a full-bodied dead lion. The third one says that with my abilities, I can put life into this lion. And then he starts chanting his mantra. The fourth friend is a wise friend. He goes and climbs a tree. After the chanting of the third guy is over, the lion becomes alive, is extremely hungry, kills all the three and devours them. This is a Panchatantra story, and this is the Sinha Karak. Varam buddhirna sa vidya vidyayam buddhiruttama buddhivina vinashyanti yathate Sinha Karakaha. Arthat, we have the learnings, but learnings without wisdom is useless and disastrous. Let us therefore endeavor to put our learnings and wisdom together when we try to proceed from IMS to CMS. Thank you, ladies and gentlemen, for listening to me very patiently. If you have any questions, I will be very happy to answer.
Thank you, Colonel Tatwadi, for very nice point-wise presentation, giving clarity on yesterday's discussion and putting out your views. Questions? Any one or two quick questions?
See, as a task force members on that wastewater reclamation, not regarding the presentation as such, but because you have mentioned that the issues of water management, where you are talking of again bringing it and taking as a makeup water. So by introducing wastewater, definitely it helps. But as you are handling the task force for wastewater reclamation, now some of the states like Gujarat is there, Karnataka is there, they have moved ahead even better than Maharashtra. They are talking of 20% at least to be brought, so that 20% reduction will happen. So any thinking of having parallel networks in cities now because of that? Otherwise, this will remain only for some of the consumers, maybe the non-domestic or industrial. So unless that change happens, having a parallel networks in a city, I think things will not improve. So any discussions are happening on these aspects?
Sir, to the best of my knowledge, I do not think so. The problem is that there has to be an enforcement of the reuse policy, and part of these funds must be earmarked by all the ULBs, by all the states, by a directive from the central government for enforcing reuse within the ULBs. Otherwise, the policies, the Gujarat government is doing that. In Maharashtra, there is this initiative of supplying to the industries and the thermal power plants within 50-kilometer radius. That is what the policy says. But unless some such policies are, policy directives are there from the government, I do not see much happening. Industries are already facing problems and they are not able to expand because of reasons of water shortage, which is a fact. In fact, in Mumbai, your RCF is taking about 50 MLD from the MCGM raw sewage, treating it to industrial water standards, which is very much like the drinking water which is supplied to us, and using it for their industrial purposes. I have worked with many textile industries for their wastewater reuse reclamation to the extent of 95%. But unfortunately, in the urban water sector, there is not much movement towards reclamation for reuse, and in fact, the reuse can happen in across several purposes.
Okay, thank you, Colonel.
Myself, KB Wadhavne. Some of the observations which you made, they are correct or might be correct. But one observation I do not agree is he talked about whether there is any quality monitoring. It is not happening. No, his answer was no. So I worked with BMC, and I do not agree to this because over 6,000, 7,000 samples are tested in a year. Zone-wise testing is also there. Then every year, what is the contamination level, that is being checked, and we have improved a lot in that. So grossly saying no, I really do not agree. Thank you very much.
Sir, you are an exception that proves the rule. MCGM is, renowned for its water quality. MCGM has been acknowledged as
But
the
the-
best quality water because of your testing regime. Unfortunately, many and most of the ULBs do not have the kind of testing regime which you enforce in MCGM. I am living in Mumbai. I know about the MCGM
But
water
sir,
quality.
you in your presentation, you
Yes.
straightaway mentioned the answer as no. So that was bit. Thank you, sir.
If I have hurt your sentiments, sir, I am sorry.
Thank you, sir. No matter.
Last question.
Thank you for your presentation. I am Adil Mohammed from Odisha. You are telling that when demand requirement demand quantity will be supplied, we will stop the supply, so that there may be right arrival people to collect the water. If you hit the demand quantity to supply, then you are restricted to 3.15 and you have supplied 3.1 and then stop. If you declare this, there will be right arrival people to collect the water. They are fighting between poor and richer. Is it considered?
Sir, we talk about water supply.
Yeah.
We have a scale. Even for the informal sector, which we may call a slum, there is a scale. You are supplying water at some scale, right?
Yes, yes.
So far, so good?
Yes.
Okay. Next, if you are supplying to a slum which has a population of 10,000 at a scale of say 55 liters, you will supply say 550,000 liters. Okay?
Yes.
That how long you supply will depend on the supply norms of your particular ULB. They may be different in Mumbai, they may be different in Calcutta, because slums are typical urban issue, right? Once you have supplied that quantity of 550,000 liters, will you still continue supplying? You may, if you go take the human angle. But as a water engineer, do you have the water to supply?
For intermediate, we are doing this. For intermediate supply, we are restricted the quantity of supply because 2 hours we are supplying. If you go to continuous supply, that time we can do or cannot do.
That time, if you are supplying the same quantity in 24 hours, definitely you are going to reduce the rate of supply.
Okay.
I also spoke about some peaks in the supply regime. If you have peaks of for say 4 hours, okay, then for those 4 hours, they will also get at a much higher rate. That is the time when they will collect the water.
For revision of these guidelines, you have to consider this is actually better to be. For revision of the guidelines, you have to
Yes, sir.
suggest a suggestion. If you consider or you already considered.
I would presume they have considered it.
Okay.
Okay, thank you, sir. So we move on to the next speaker of this session. Again, coming from the industry, having a large number of year of experience. So I invite Mr. Sandeepan Chaudhary, who is a postgraduate in civil engineering from Jadavpur University with specialization of environmental engineering, has over 26 years of experience as water industry consultant. He began his career at Development Consultant Limited and has worked with renowned consulting firms such as DHV India, Stoop Consultants, LASA and WAPCOS, and also as a consultant to the Asian Development Bank in Manila and Indian Resident Mission. Throughout his career so far, Sandeepan has involved in more than 16 internationally funded projects focusing on water supply, wastewater, fecal sludge management in India, Nepal, Bhutan. So his interest lies in network modeling, SCADA, digital security of water systems. So I invite Sandeepan for giving his talk. He'll be talking on flexibility in design of water distribution systems.
Thank you, sir. Thank you, Chairman, sir, my co-speakers and the learned audience. Thanks for giving me the opportunity to share my thoughts in this very esteemed seminar. So basically, we have heard a lot of discussions since yesterday regarding the debate between CWS and IWS. Well, the debate, I think, will continue, but what in my presentation I am trying to highlight is the basic design philosophies and how it differs and affects the design for both CWS and IWS. Now we do not have a specific guideline for intermittent supply. That has been very clearly uttered by several speakers since yesterday. And we mainly design presently on the following basis: peak factor 2.5. 2.5 is the recommendation in the new manual for continuous water supply. Otherwise, we take 3. Minimum pipe diameter for urban areas 100 millimeter. Hydraulic gradient 2 to 4 meter per kilometer. Staging height of the overhead tanks 20 to 24 meters, typically 22. Residual nodal pressure, generally the present manual's norm is 7 to 12. There is recommendation now to raise it further. I am not going into that because that kind of design is still not produced here. And we try to minimize the storage capacity and control. Control is the main thing, which basically gives the total concept of the design. Now we have many systems designed as continuous water supply system but operated as intermittent water supply system. What happens? The duration of supply is mainly 6 to 8 hours, 3 plus 2 plus 1 or 3 plus 3 plus 2. And as a result, the peak factor becomes 3 to 4. And all these converted CWS and operated IWS are through the OHRs. That is, the supply to the consumer end is from the OHRs. That is why I have put up a very typical known picture showing overhead reservoirs supplying to the households. Till now we have very few examples of direct pumping or through hydropneumatic systems. Maybe some exists, but most of the systems, including the much highlighted Puri 24/7 water supply, that also depends on overhead tanks as far as data is available to us in the public domain. Now I am talking about a particular area in Kolkata from where I belong to. Kolkata metropolitan area is a little more bigger than Kolkata. Kolkata's coverage is only, Kolkata Municipal Corporation's coverage is only 187 square kilometer, and this Kolkata metropolitan area is 1886 square kilometer. It is something in the line of Greater Chennai Corporation or Bihar Mumbai Corporation in this line. And there are 38 ULBs and 4 municipal corporations, including the Kolkata Municipal Corporation. Now, if you look into these water supply service levels at present, you will find that most of the cases, the average supply hours are varying between 8 to 10, in some cases 6, 4.5. Kolkata actually has a very widely varying supply hours. In some cases it is 22, in some cases it is 4, so average you can take it as 8. And all the areas has quite high coverage, that is there, and per capita supply is not too bad. Why I am trying to highlight Kolkata metropolitan area for this presentation is that it is not an water starved area, or the area as a whole. West Bengal is a water scarce region, but this area has the Hooghly river flowing through it, so there is enough water to supply to both the banks and the whole habitation. So water scarcity is not the reason for limited supply as such. And the most important thing is there is almost no metering and no pricing. So I now quote from a CAG report. This report was published in 2018, available in the public domain. And all these 6 projects which were constructed in the KMA region under the JNURM, where 24/7 was one of the criteria, that shows that presently the operation is for 4 to maximum 10 hours. And CAG has made an observation that all these areas were designed for 24 hours, why the flow is only for 4 to 10 hours. And if you look into the third column, hours of operation of the WTP, you will find the hours of operations are quite high. It is in some cases 20 hours, it is in some cases 15 hours. So water production is there, but supply duration is much less. Now, we try to find out what is the reason. We tried to talk with the authorities several times, but there was no specific technical reasons as such. What was find out that lack of resource once the JNURM was over, poor operating ratio due to the lack of tariffing process. So lack of resource is there. So manpower is less. So maintaining 3 shifts is a big issue. Power issues, as just a little while ago highlighted by Colonel Sir, is a big issue. WTP is not operational for 24 hours, but still that is not a major reason. And no valve control, as such manual control or SCADA based, and quick emptying of the tanks has been noted as a complaint. And inequitable supply, unwillingness of the consumers to install ball valves, and I wrote it wrong, it's float valves. That is the reason for huge loss from the underground reservoirs. And then there are undisclosed reasons which are mainly attributed to socio-political pressures. Okay, so what we find out that the main reason is unwillingness to install controls in the household storage, and also there is unwillingness from the users to do away with the household storage. Now, this is a scenario. Now we go into how generally the design is done. Design is done, most of the projects which are presently executed under JJM or Amrut 2 or for any other funding agency, the typical method of load distribution is any of these 4 methods. So why I am first taking up or picking up the load distribution, because load distribution controls the pipe diameter, it controls the peak factor, and it is basically the backbone of the whole design. So what we generally do, we either divide the total peak flow uniformly among all the nodes, or we use the unit load method. This is the most popular method used in JJM and Amrut. Actually, I even carried out survey between different government agencies, and they said, okay, unit load method is the most favorable one. So what that does, that is a length-based weighted average for distribution of the total load among nodes. Then there is Thyssen polygon, that is an influence area-based method. And in some cases, after the network is designed, customer meter based verification has been done, but it is something like to be wise after the event, because once your system is done and you have no customer meter data, you can only do this for an existing system. If you install the customer meter when the system is operational, get the data and then redesign the system, then that is useful, but that is seldom done. So we take up a very small study area. This is a real area. Why I picked up this area? This is a real area implemented in a funded project near Kolkata. It's a peri-urban kind of area, not a total urban. So in the leftmost one, we are showing the project area. Then the basic network. It's a very simple network. Pipe diameter varying from 250 to 63, and flow is from OHR. And if we look into the whole system, the peak flow is 37.5 liter per second, that is 3.24 mld, really a small area. Peak factor is considered 3 here since it is a very small area. There are 2 DMS. The analysis is done on the basis of steady state analysis, and minimum pipe diameter is 63. It may raise some eyebrows, but since it is an peri-urban area and there were quite a few areas which are getting very less population, this was the design consideration fixed by the project authority. So what we find out that the minimum residual pressure is 12.9 meter and hydraulic gradient is 2.86 meter per kilometer. So it is more or less very simple, and if you look into the distribution of dia-wise pipe lengths, you will find that small diameters are dominating almost 75% and the maximum diameter is 250 diameter, which is the pipe going out from the overhead reservoir. This one, the rightmost file, the rightmost picture, the brown one. So I am also showing here the habitations and house connections which were envisaged during the initial household survey. Just to give an understanding that when this analysis was done, we already have the household data and possible house connection indications, but that was not used. So what we now do is a random demand model. What is the basic idea behind this random demand model? That in the earlier one which we have showed, it is a totally demand driven model. So we are expecting the customer to consume as per our design assumptions, which is really unlikely because the consumer will not consume water as per our wish. So we have considered a typical consideration 10 liter per minute with 10 meter head. This is basically the 24/7 design criteria of what UK. UK is very mature in terms of 24/7 water supply, and it has a privatized supply system. They have several criteria from service point DG1, DG2, and this is the DG2 criteria. Now how we do it, because we have many nodes, and if we put 10 LPM nodes, the peak will go much and that will violate the basic assumptions, etc. So what we do, we have done a random distribution, that is keeping the peak flow constant at 37.5, which was earlier assumed. We randomly distribute the total flow among some of the among all the nodes considered in the network. So as a result, what happens is that some of the nodes are getting the flows and some of the nodes are not taking any flows. This is actually a real situation, that some of the taps are open, some of the taps are not open, or some people are taking water, some people are not taking water. If you think about the typical Horner's curve which we used to utilize for plumbing situation, this is some kind of that kind of situation. And again we do the analysis for the steady state, and this random string is a really random string generated using some cryptographic tools, so it is a sound random string. And what we find out now, the pressure gets reduced to 11.35 and maximum hydraulic grade is as high as 6.8. So if we find that some of the people in the area are getting supply at a standard rate, then we find out that hydraulic gradient is quite high and some of the other peoples will not get supply. Zero means that some of the other peoples are not getting the supply. So now we see what are the reasons behind this. We find out that there are some stretches which are having higher hydraulic gradient than the last steady state analysis, that is 2.8 meter per kilometer, when we did with that steady state uniform distribution kind of thing. And as a result, the total pressure is dropping. So we made a modification. So if you look into the table presented here, we find out that with modification we can achieve the pressure as high as the last time, 12.78, and maximum hydraulic gradient is now reduced to 3.7, that is well within the limit. But what we have to change diameter of a number of pipes, and it is not only the minimum pipe diameter, it is also the higher diameters. So why I put this comparison, that sometimes we try to give a norm that if we increase the minimum diameter of the pipe, that will possibly give a better residual pressure at the consumer end. That is not actually true, because when you have a higher withdrawal rate from the consumer end, it is affecting the whole network. So it is not a norm-based design, but a serviceability-based design which can ensure your residual pressure. Now, what I will suggest at this point of time, it is not very difficult to modify the design like this, because if you carry out 4 or 5 random trials with different kind of combination of nodes, nodal demands, then you will finally get a stabilized situation. And I can highlight, you can also calculate it basically that with 0.166, which is the now uniform load considered for the nodes, it is basically 2 to 2.3 times than the average nodal demand considered in the normal condition. So this is one example how you can basically give more robustness to your system. And if you design this system in this manner, one thing is very clear, that your peak factor issue is not that critical. What is the IWS peak factor and CWS peak factor? So if you design your system based on this residual supply of 10 LPM, which is a very standard thing, then even if you design for a continuous water supply system, and if you operate it in intermittent water supply, and the peak factor is even as high as 4, that may not be a very difficult issue if you provide a little bit of control, because all the users will not get water simultaneously, but it is still possible. Now we investigate a little more further. We consider a tank model. It is a pressure-driven analysis. It's not a demand-driven analysis. In the tank model, what we do, as I mentioned earlier, we have the identified households and house connections for the basic network. So we put small tanks. These are simulating the underground reservoir kind of things in all those consumer ends and connect it with the nodes of the basic network. Now you can see the tank data which I have provided. It is a very small tank. It is symbolic. The tank is not a very significant thing. You can further reduce it also. Only thing with this tank, it is around say 1000 liter capacity or 1 meter cube capacity kind of tank. What we have basically tried to do with the tank is that it's a accumulating unit or accumulating entity which can do the analysis, and then we replace the OHR with a reservoir having the same hydraulic grade line, and tank connections with the pipes are, with the main pipes are 20 millimeter, keeping in mind the ferrule connections and all these things. And we carried out a EPS analysis for extended period simulation for 12 hours. We have to do extended period simulation since tanks are accumulating, so the system needs to get stabilized and see how it happens, behaves. Now what we find out that I think you can see properly that if I take the outlet line from the overhead tank, the flow is slowly decreasing and it is an uncontrolled flow from tank. Why I put up this picture? Because when we talked with the engineers, they many times mentioned the tank emptying very fast. So this is a reason that if you have uncontrolled flow, the tank is emptying very fast. Then we give a picture. It's not a Picasso picture, it is just a picture showing all the tanks filling up times. That is when the tanks are 100% filled. So you can very well see that by 8 hours all the tanks are almost filled up, almost not filled up, and thereafter it is steady because we are not putting up any demand from the tank. And this also gives an explanation why the flow is slowly going to zero. So if you operate your model in this way, then you have an idea that what is actually happening here, because you do not have control in your network, which is quite common. We do not have controls most of the time in the urban, small urban networks, and your tank basically empties as per the natural gradient which controls the flow. So if we now look into the situations, some of the tanks, we find out that hydraulic gradients are very high, and some tanks which are taking 3 hours to fill up, if we just replace this one, this color is not visible, this is a 63 dia pipe, if we just replace this with 90, then the tanks are getting filled up quicker. So basically again, so the network topology, diameter, etc. are getting controlled by the natural flow. It is not your peak factor. Now we put a little bit modified model, a tank model with flow control. At the outlet of the tank, we fix a flow control valve and assign the flow control valve a flow of 37.5 LPS, which was same as the original steady state analysis. And now we look at the outflow from the reservoir. And what we find out, it is mostly steady and lastly it is slowly dwindling, but it is not coming to zero. That is very important. Now if you look at this picture of tank filling, you will find that lot of tanks are not getting filled up. If you look at the rightmost end, there are still tanks which are filling up. And I take a particular tank with control and without control. You can see that tank at the somehow it's in the end of the network. So with control and without control, you can see that without control the tank is filling up, but with control the tank is not getting filling up. So what network details we have designed for is not being able to take this kind of natural operational condition. So I am not concluding. What I am trying to say is that instead of debating about IWS and CWS based design, peak factor, minimum pipe diameter, the basic considerations, we should focus more on the actual serviceability condition based design and the design which is taking care of the control system which is available in the field. And if we design for that, maybe the peak factor will be much higher, and even if we design for a CMS, the continuous water supply system, it will not be too difficult to operate it also for IWS system, because any IWS system cannot reach the CWS level in a single jump. It will go through stages. So we have to design a system in such a way it can survive both situations. That is what was my point of presentation. Thank you, sir.
Yeah, thank you, Sandeepan, for first of all technically laying out the how the models can be tweaked to take into account the field conditions. You can have tank models or any other such kind of hydraulic elements that can be added. So any questions? One or two questions? Lights, please. Yes, Sonani sir.
See, in all distribution networks, when we prepare the hydraulic model, these are the end links where we give the 4-inch or 100 mm diameter. We always face this that there is a low velocity, okay, and still it's a long length of 100 mm pipes. Even if we do for the over network level, 60% goes to 100 mm. Now reducing it to 75 to 63 is one way to maybe increase the velocities or maybe to balance the pressures. But the another thing which is a constraint in that is how many connections you can provide on 63 mm diameter pipe or 75 mm diameter pipe. So that constraint we need to check it if we are coming down to be less than 100 mm. Otherwise, because of that constraint, we have to go for invariably to 4-inch diameter pipe.
Yeah.
Yes, sir. Actually, here the 63 dia was practically this project's particular condition. I am not proposing to reduce it, but what I have also find out in we have designed 38 zones in one project, and what we have find out that it is possible to judiciously reduce the pipe dia if you look into the distribution of the habitations, and it is justifiable in some cases because some pipe dias are so less utilized, that it will be loss of money, because our major purpose is to cover as much as possible. So I do not think we can always avail the luxury of reducing to of availing the pipe dia of 100. And if you look into the present guideline, the CPHO's draft manual is suggesting 100 for the urban, whereas it is 80 for the rural. I do not really know, as Cornel sir also said, why this inequity is, because it is 24/7 for both the cases. Maybe the demand is much less, but again, when you are doing for the peak, it should be same. So that is not exactly the thing what I am trying to highlight here. What I am trying to say is that it should be based on serviceability as well as the control available in the field. So that will decide how your network topology will work. That's all.
Okay, thank you.
Thank you. So, thank you, Sandeepan. Thanks for your talk. We'll move on to our next speaker, who is again coming from industry and has wide year of experience, and no introduction needed here, but just to complete the formality. Dr. Ullas Naik is ex-editor of IWWA journal with more than 30 years of experience in design, research of water and wastewater network systems. Besides working for pipe industry for more than 27 years, he has done his PhD in operation research and application of water supply systems from VNIT Nagpur, and he is a B Civil and ME Environmental from VJTI Mumbai. In past, he has worked as a consultant for World Bank, Tata Consulting Engineers, and also worked as an expert member with various government of Maharashtra committees. He is a co-author of technical book Design of Pipelines, published by Mumbai Center IWWA. So I request Dr. Naik to give the talk.
Good morning once again. I will be presenting on water supply system design and operation, especially on the outset of the debate that is going on IMS or CMS. It's not a debate actually. We all aim for a continuous mode water supply system, and it should be in a place, I can say, as a basic human right, but we should also understand the constraint behind it and accordingly plan our design operations and go for it. My focus will be on urbanization, housing trend, and the mode of water supply, the way we choose, and water supply system operation. This is just to summarize. This is how typically we do the design. We have been doing designs for so many years. There are CPOQ norms, there are norms by sometimes World Bank or IWA, AWA, and so many places. And these are more or less in a typical way. The transmission system is designed with respect to availability of electricity for 16 to 22 hours with a peak factor of 1.2 to 1.5. And distribution system, the LPCD norm, peak factor sometimes 2.5, sometimes 3, depending upon the population and other factor. And residual pressure, sometimes 12 meters, sometimes 17, somebody is saying it should be 21. It goes on. And we do very diligently, the design in a continuous mode water supply system. There are packages available in past. There were loop package were available. Consulting firm were having their own package. Thereafter, the softwares available from international market, and we have been using it. So using a software and doing a design, continuous mode water supply system is something college pass out with 2-3 experience. Right from that to up to 25-30 year experience engineers can do. That is not a big deal. And we do it. And we straight go for the implementation. But best of our knowledge, for last 35-40 years, despite we aiming for continuous mode water supply system, we are unable to do it. The reason, I think one of the presentations you have seen, I think Mr. Sonane gave the presentation of Hyderabad city. We projected something and how we achieve. There is a gap. There is inadequate water availability. Sometimes there is a lack of funds and you can't complete the implementation. Sometimes you have projected something that your city will grow in this way, that way, but certain pockets suddenly pick up highly unprecedented urbanization, and that is the typical case of our Mumbai city itself. Increased population in unspected pocket, rise in demand in water, and compel expansion of distribution system because of political pressure, because of sudden growth in certain pockets, and also this is what we have to address. We only focus on design, we only focus on the prerequisites that are required for the design, and these are, yesterday one of the presenter, I think, I forgot his name, he was talking about we are cutting off ourselves at a municipal limit, and there is something more to be done beyond municipal limit. That is the typical leakages at house connections, some. Then sometimes our ESR of municipal water distribution system run short, and then we have to, that is one of the constraints. Power availability, wall operation, if you are not planned in first place properly, then also it is a problem. And total all-inclusive approach is another problem. Now urbanization, this is one of my focus. Rapid urbanization is not a common, is a very common phenomena worldwide. India is also leading. It brings benefits, but it exerts problem on infrastructure. And especially in India and worldwide also, it is driving vertical growth in our cities. The way we design, especially for the water supply, the way we design, and traditionally we are designing in that way, and the vertical growth, there is a mismatch. Typically, and today also we talk about, we will go for continuous mode water supply system, and with that, you can increase the terminal pressure requirement, but you can cover at the most early days 3 over 2 floor, 3 floor, 12 floors. But how much? How many more you can cover? As per the prevailing CPHU norm, you could have covered ground plus 2. With the revised norm, you can go for ground plus 5 or 7. But the way our cities are grown, even if you increase the terminal pressure, with that perspective you can think you can cover a better coverage so that people can directly take water from the taps. But at the same time, so many buildings has given up for high rises. So where is the gain? Unnecessarily we are pressurizing the system on higher side. There are so many reports available, so many. Rise of tall building. Even our urban planning Department of India, they have published the report. So many international papers are available which keep on talking about how the cities are growing, how vertical growth is happening everywhere, and this is what the scenario is. Of course, Mumbai is leading in the high risers, followed by other metro, and this is going to be the phenomena for the other cities also. Yesterday, there were presented from PCMC. He has worked on one pocket, and he is very happy on that. And that was a typically flat ground plus one structure, where he could easily avoid the sump and tap water was used, and they were happy. And the consumers were also giving an elaboration how the changeover has happened and how they are happy. But PCMC also had high risers. How they are going to address that problem? Typically, these high-rise buildings receive water only at their sumps, and they have their internal pumping arrangement to cater water overhead water tanks. So even if the water authorities, by hook or crook, try to provide continuous mode water supply, it will not be to the individual consumers, it will be to their sump. And once it is delivered to the sump, it has got no impact downstream of the sump. We generally design for this, and we land up on this. This is the fate. And what we do? The terminal pressure, which is very high, which could have serviced ground plus 2 or 3, we are compelling it to drain it into the sump with a very high flow rate. Over a period of time, especially in Mumbai, and maybe similar case in other towns also, the people are habituated to receive the water in their sump and then pump it and use it. Suddenly, if you start giving a flat rate water supply to them, because they need that water at a flat rate, their some capacity will be running short, their overhead tank may overflow or run short, and the whole purpose may get forfeited. So this is typically they receive the water in the sump, then there is a pump arrangement. Then in Mumbai, at least we have seen every flat has got a loft tanks, and eventually the water is stored in the loft tank also. And your that peak factor and everything is applied on that loft tank, not on the municipal water distribution last main. And if it is very clear in front of us with so many reports, and we ourselves, whenever we move in any city, the way the cities are vertically growing, why we want to ignore the fact that we are going to supply these buildings in their sump only? Besides that, this is the municipal law, especially from Bombay Municipal Corporation and followed everywhere, that they give permission to construct a building, small or big, and they, in that case, they must have some storage and overhead storage. They have specified the capacities also, and if it is not in place, construction clearance or occupation certificate is not given. So they are going to construct, and they are going to use it. By just claiming that we'll eventually make them bypass and this, that, but these are already there. Again, we should, from the water supply perspective point of view, whenever we are going to design for any city, we should basically divide the city with respect to their growth pattern. There are certain greenfield cities which are new, like Chandigarh was there, or Navi Mumbai, certain pockets are there, which are planned with all perspective kept in the mind. There, these all experiments are welcome, rather should be done, must be done. But there are cities which are going 50 to 75% growth in horizontal direction. There also such experiment or such design should be useful. But there are other cities which are going 50% or 75% growth in vertical direction. So, and at the parallel same time, there are certain cities where remarkable pockets have been kept, where we can expect the growth in a vertical direction, the rest will be in a horizontal direction. Or it is a mixed pattern. Knowing well the way the city is growing, the way the town planning or the architects are thinking about the growth, we should choose the design pattern. Besides this, as I spelled out earlier, you have designed everything and now you are implementing the scheme. Now, since yesterday the rains have started, otherwise the whole Maharashtra was facing a drought. So your yield is going to be down. So in that case, the water has to be rationalized, has to be distributed over till the next monsoon comes. That kind of scenario exists. Then you have to ration the water, that means you have to curtail the water. And the moment you have to ration the water, your supply hours are going to go down. So you are compelled to operate the system from continuous mode to intermittent mode. Sometimes your entire network is not either replaced or rehabilitated. Storages that are required for 24/7, especially the ESRs, they are not in place. Consumer metering, I think lot debate has happened. If that is not in place, again another problem. Service connection, this is one of the prime source of leakage. If they are not replaced throughout the city, there is a problem. And volumetric traffic, because unless the consumers don't understand, they are charged for excessive or wrong use of the water. If all these parameters are not in place, you are compelled to operate the system in an intermittent mode. So, the need is different type of solutions are required with respect to housing trend and their spread in respective category cities. Result from greenfield cities or from small pilot pockets should not be generalized, should not be made flatly applicable across the length and breadth of India. Flexible mode operation should be adopted. See, we designed 24/7 water supply system and it is written on the FET, at least for the 95% of the town, that till they achieve the design parameters, they are going to operate it in an intermittent mode, and having achieved and having stabilized for some time, and thereafter again some problem happens, they again have to switch over to intermittent water supply mode. So the design itself should be in a flexible mode. I think my previous presenter tried to put a highlight on it by presenting a model, hydraulic model. So the thought process is coming up. I am happy on that. My suggestion is the intermittent water supply is very common. So we should, and we also know the advantage of continuous mode water supply. So we should take the best combination of that right when we are designing the system and planning for its operation. So this is something not came from my brainchild. I have seen how Bombay Municipal Corporation, where we witness a continuous growth of the city in a vertical direction, in a different pocket, unplanned growth. You can identify any problem that exists in the Mumbai, and still water supply reaches to every consumer. What they do, they have done a supply grids, and that grid is most of the time are water filled, and from that supply grid, distribution grids are charged, and from that pocket to pocket intermittent water supply is achieved. Such type of planning has been evolved over a period of time as a good solution to cater the problem, and it is helping. My suggestion is, this is evolved, but you can plan it in advance, taking a clue from it and design your system. This is what typically is a schematic way only. This is how the main grid, the dark pipelines are supposed to be filled continuously, and from that pocket to pocket water supply should be made. So you are taking a good advantage of continuous mode water supply system to good extent, and also addressing the intermittent water supply mode problem. Your main grids are most of the times properly laid, properly attended, and they have got less leakages. And even if they are charged with 100% the 24 hours water, there will be less leakage. And the thereafter system, which is also have leaky sumps, connections, and so many other things, they will be exposed to limited hours of supply. Till you address those problems, and then slowly switch over everything to continuous mode of water supply if you have achieved everything. And in case of a problem, you can come back also. That flexibility, resilience in the design operation should be in place. This is typically the peak factor that will be applicable if you do composite type water supply system. Your main grid will be on a lower peak factor and your supply grid will be on the little higher peak factor. And when they both operate together for so-called continuous mode water supply, whenever it is achievable, possible, then you can still maintain the same pressure. These are typically a small calculation I have tried to put it for that capacities. Of course, even in continuous mode water supply, you need lot of wall operation, and intermittent you have to. So, these are the wall. Of course, on intermittent mode, daily you have to operate so many walls. Continuous mode, at least on few location you have to add, and that is for the pressure reduction purpose. Composite mode, there is again a combination of both. You can go for more and more smaller zones and more and more equitable water supply, because moment you have to do a rationing of the water, you are switching out to intermittent water supply mode. And moment it is an intermittent water supply mode, the first curse is inequitability in water distribution. And for that, pressure control measures is the only options most of the places. So you can go for more and more small zones, but then of course your wall operations are more. So you should have a judicious view how much to go for equitability. Moment you go for composite mode operations, these are the advantage. Your peak factor is lower on the main grid while it is higher on the supply grid, and if you put together they can give a results. Your network can cover better areas, flexibility of timing can be done. Uniform pressure in equitable water distribution. Contamination is minimized because that problematic portion of the supply network will be exposed for a few hours. That's all.
Thank you, Dr. Naik, for very nicely laying out the other alternatives of practice and design, such as composite water distribution system. And it is also practiced in a city like Mumbai. So a lot of learnings can happen from different cities in India. So any questions from the audience?
Hello. I won't say that it is a question, but I am here more to support Mr. Naik because he has presented a very all-encompassing points on water supply, transmission, distribution, both. Rather, he started with the supply to multi-storied towers. And I just remembered that 4 or 5 years back, just opposite the Bhaikhala yard of MCGB, there is one building which has come up, and that tower they have placed in the ground floor compound pressure filters, and they are collecting kitchen and bathroom wastewater there and treating it. They have put another tank on the terrace, and after treatment they are sending that treated effluent to the tank, and from there only for flushing purposes in the toilet blocks they are using that water. So when these people say that these are towers are like a village, you should perhaps design their systems with 100 LPCD when they are giving that service of treating the wastewater partially and reusing it. So that was one point which should be thought of for maybe for, they call it Upper Worli or Lower Parel, that region. And because there is suddenly a large growth in water demand that has come in there. regarding the composite system, that's one thing that Bombay Municipal Corporation, while putting in this composite system, they have also thought of saving on their power cost by having tunnel in the water system and stopping their booster pump at Malabar Hill, which is one of the major power consuming station that it was there, and which used to supply water to the Malabar Hill reservoir, which supplies more or less entire South Bombay. So this was one another point which can be considered. Thank you.
Thank you. Okay, so thank you. Thanks all for all the speakers who have given very nice overview of their very large experience working in this sector, and very good point they have made with some suggestions on the issue of continuous versus intermittent water supply. Now I hand over to the Vaid sir for further announcements.
Thank you, sir. The first session is over now, and I would like Patade sir to come to felicitate our speakers. Please, we will felicitate first Colonel Bhaskar Tatvavadi. Then Mr. Sandipan Chowdhury, please felicitate sir too. Dr. Ullas Naik. And moderator Dr. Pradeep Kalba. Now there is a tea break. Tea is arranged outside here, and we will come back 11:30. And there is a stall of IVA publications. Those who are interested may take books, purchase books. Thank you. नहीं इथेच आहे. Session 4 modeling water
रवि 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 थोड़ा पीछे कर, तू आ रहा है इसमें, और जा पीछे, और जा थोड़ा और पीछे लेना, बस 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 बस
Welcome back to delegates.
लाइट
Now we are going to start our
Sir ji.
fourth session,
Mr. Vai.
which is on modeling water security and
Light,
GIS
light.
applications. I hand over my
लाइट
to moderator, to this session's moderator, Shrikant Argade Sahib.
Hello everybody. We had a very good opening session today, and now we are starting the second session of the today. Modeling and water security and GIS applications. So first speaker for this session is Dr. Anuj Kumar Ghorpade. I would like to invite him for talk. Anuj Ghorpade is talking on hydraulic modeling and pressure management. And I will just briefly introduce Anuj. Anuj has completed his PhD from Center for Urban Sciences Engineering, Indian Institute of Technology, Bombay. His research focused on improving the water supply systems using hydraulic isolation structures. The research work was focused on developing advanced hydraulic interventions for enhancing the performances of water supply systems in India. In this regard, he has been working closely with the government engineers throughout India. Along with the research group, he has successfully implemented one of the hydraulic isolation structures, that is Sharp at Safari, Palghar district, Maharashtra, India. The project was funded by the Department of Sciences and Technology, Government of India. Based on the outcome of the research work, Dr. Anuj has published multiple peer-reviewed research articles in reputed journals. Also, an Indian patent is filed for and is under review. Recently, at our annual convention 2023 held at Pune, Dr. Anuj has received Best Paper Award. The technology developed from Anuj's PhD work for improving the pipe water supply systems in India is recommended by the Ministry of Jal Shakti for implementation in all the states in India. Similarly, Maharashtra Engineering Research Institute, MERI, Government of Maharashtra, also recommended to implement it in state of Maharashtra. Dr. Anuj has co-founded the startup Agiom Water Private Limited with his PhD supervisor, Professor Kalwar, to scale up the technology developed from the PhD work. As of now, technology is already replicated in 6 locations in Maharashtra through various funding. Moreover, West Bengal Public Health Engineering Department, Government of West Bengal also appointed the startup to provide a solution for the large-scale water supply systems. So, welcome Anuj, and enlighten us with your talk.
नीचे
Good morning everyone. Thank you sir for the introduction. So I will be talking about advanced hydraulic solutions for pressure improvement in water supply systems. As discussed yesterday, there are a number of reasons for failure of water supply system. I won't go into it, but just a pictorial view that deteriorated infrastructure condition will reduce the service quality, which in turn impacts the consumer satisfaction, which is directly linked to the revenue generation. If consumers are not satisfied, the revenue won't be generated as per the expected, then it will hamper the operational maintenance, and again the infrastructure condition will lead to it. So this is the vicious cycle. Yesterday, Professor Kalbal must have discussed in detail. So we have developed, there has to be some way forward. We haven't just stopped here. So as per our 5-6 years and over years, what we have understood, first thing, it has to be adequate and quantity and prescribed quality 24/7 water supply. There is no debate in that part of the system. However, the direct conversion, like from current scenario going for a 24/7 with some external services, that's the major problem. There has to be an intermediate step to bridge the gap between the current scenario and what we have to achieve. Though it has to be a systematic approach. So once a reliable and equitable water supply is achieved, then a gradual transition which can be a sustainable for long term into a 24/7 can be achieved. So for this, we have developed a few new methods for modeling. First, we did for hydraulic analysis. Whatever water supply system, we have to analyze it, what are the problems, and we have some field demonstration like shafts, multi-outlets, and manifolds. So as I said, first thing was the flow starve condition. Again, yesterday, you must have understood what is a flow starve. Like the ESRs get emptied within few minutes or few hours. So how to model that? So for that, we have developed a hydraulic modeling technique at our. So we consider such a sample network, which is a real case network. Ideally, what we do, there are different analysis methods, a demand-driven analysis method, a pressure-driven analysis method. In pressure-driven analysis method, there are a number of methods. Someone considers a specific pressure, that's a threshold pressure, about that everybody will receive with same quantity. Again, there is a performance-based analysis. So there are a number of different variations in pressure-driven analysis as well. However, all the variation don't cover what the exact scenario of this ESR is filling. As you can see on the right side, the outlet pipe, it's not filled till the LSL. It's filled somewhere below the LSL. So what we have developed, how this impacts the water distribution network or water distribution network completely, this thing we have modeled. For that, as I showed, we have considered real case study, and this was our comparison. As you can see in the demand-driven approach, what it shows, irrespective of the water level in the outer pipe, the demand will be satisfied. It won't consider the pressure regime itself. And coming to a PDA, it considers, but up to a certain extent. Some people will get water, some people won't get. But what we have understood that some people drastically, this is what happens. We got the consumer satisfaction ratio. As you can see, somewhere it's up to 11 times, more than their base demand. Some people will get 11 to 12 times of their base demand, which impacts the other people. Which you can see, some people are deprived of water. That's what we known as the term inequity. The major reason for this inequity is the hydraulics at the ESR itself. And to demonstrate how it happens, this is in the public domain. Those who are interested can go through this research article. It's been recently published. And moreover, we did this modeling in-house. This is a Jaltantra software developed at IIT Bombay. It's a design and analysis both software, but mostly used for design software. So in incorporation with this Jaltantra and EPANET, we have developed this methodology. And this, I will show you a case study from West Bengal, where we have applied this methodology, and we got substantially good results. This was a designing part. Next, coming to how an operation has to be done, a multi-outlet storage tanks. As you can see, typically this is the MBR and the ESR. A typical practice from a ESR is to get an outlet pipe, and at the bottom of the outlet pipe, on the horizontal level, we do multiple wall operations, and then we go for isolations. Such kind of operation results into a huge head loss at the bottom of the ESR itself, which again in turn gives rise to the inequity and the consumer dissatisfaction. So our suggestion is to provide multiple outlets at the ESR itself, so that you can achieve the LSL, which is at the ESR. That LSL can govern the hydraulics of the remaining distribution network. So the isolations can be maintained from the tank itself. A design-enabled subzone we term. Again, for that, we did a rigorous study We did proper hydraulic modeling, we did the optimization, we did the simulation. In fact, we considered a dummy, for simulation we considered dummy demand nodes. Generally we do initial, intermediate and ultimate stage. All and above we consider 1.5 times the ultimate stage, 2 times the ultimate stage. Because that's the reality on the ground. We never know how much consumer is going to withdraw water from the system. To simulate that, we have considered these 2 dummy nodes, 2 dummy scenarios. And again, we all the experience what we have done, we did it on real case studies. These was from various part of Maharashtra, real distribution networks. And this is what we found. Even in the 1.5 times the ultimate stage and 2 times the ultimate stage, multi-outlets outperform the single outlet storage tanks in hydraulic wise, and there are different parameters. That's the beauty of this multi-outlet storage tank. Apart from this hydraulics benefit, there are multiple operational benefits. Suppose in the right hand side corner, as you can see, the land use pattern is not similar. There are different land use patterns. To have for different land use patterns, we can give a dedicated outlet and achieve the improvement in the hydraulics. Similarly is the case of the ground elevation. Some part of the distribution network is highly elevated. So to serve that highly elevated area, we have to increase the pressure at the source itself, which will overall impacts the hydraulics of the system. So instead of that, we can provide a separate outlet based on the ground elevations as well. Then next, shaft with multiple outlets, how can it improve and provide hydraulic isolation for efficient distribution? I'll just play this. Yeah. This is a typical ESR. Everybody must be aware of filling of an ESR. The basic 2 function of an ESR is to store the water and to create pressure head. That's the basic principle. And we design, as per the manual, we design 1/3 capacity. All that stuff is done. But as I explained earlier, and we saw in the hydraulic modeling, the withdrawal from the system is way too much higher than what we anticipate in the design stage. So that's why the emptying of the ESR is very fast. We have seen it in multiple cities, villages across India. The filling time for ESR is around 4 to 5 hours, but the emptying varies from 40, max 50 minutes. So the solution for that at the operator level is bypassing the ESRs, huge ESRs. I won't take any names, but multiple cities we have taken huge, big, large ESRs has been bypassed. So instead of that, once the ESR is bypassed, we won't get storage and we won't get the hydraulics correct. So for alternative to this, we are suggesting to use such kind of shafts. Basically, shaft is a pipe-in-pipe arrangement. It's made of a 2 pipe. The inlet pipe, it's open to atmosphere. The water from the inlet pipe will spill into the annular space, as you can see in the animation. The water column created at the annular space will govern the will govern the hydraulics of the downstream networks. As you can see, we provide multiple outlets to the shaft, so that we can get isolation from one point, which was discussed earlier. What are the benefits of multiple outlets? So there are n number of benefits. I'll show you the case studies and then we'll discuss how this happens. This was first demonstrated through a DST funded project in my PhD work at Safale Palghar. Safale Palghar, it's basically a peri-urban area. This is where the around 10 to 11 distribution net zones were there. In one of the zones, this was the scenario. As you can see, the transmission line was coming from a MBR, 150 mm transmission line. It was supposed to go to the ESR, existing ESR, and from ESR the distribution was supposed to happen. But due to multiple reasons, the practice was bypassing of the ESR and the transmission line was directly tapped. As you can see, there were 2 outlets. One was for Nandade and on Chafanagar, the local hydraulic zone. So each wall was operated 1.5 hours daily to provide water. But instead of, the problem with this system was people residing near to this tapping point were receiving water with sufficient pressure. The tail end consumers were deprived of water. That was the complete scenario. So to resolve it, what we did, instead of these 2 outlets, we took a single outlet, as you can see in the left bottom, a 100 mm outlet from the same line. First we did the pressure measurement. What is the scenario in the transmission line? After the pressure measurement, we designed the shaft height and the diameters. So we took an outlet from this transmission line, single tapping of 100 mm, which was considered inlet to the shaft. And through this multiple outlets, we have connected the existing distribution network. So we haven't changed or we haven't touched the distribution network, just we have changed the tapping of this system, as you can see in the picture. And this was the actual constructed shaft. Not only that, we installed ultrasonic flow meters, we did household pressure monitoring. This was done for 1.5 months continuously after commissioning of the shaft to document what all changes it covers. So this was our first observation. As you can see, we go to households and we do the flow measurement. There was not much difference in the average flows in the pre-shaft and the post-shaft scenario, but it drastically reduced the standard deviation. As you can see, the standard deviation means for pre-shaft it was around 0.12, which has drastically reduced to 0.0, which what it means, the consumers residing near to the shaft and the tail end consumers were receiving water with more or less the same pressure. And moreover, the suppliers, what we did earlier, 1.5 hour, a 2-wall operation was there. We reduced it to single wall operation. We have to just turn on the inlet for 1.5 hour, and both the zones were supplied with good pressures, as you can see. And this has been working for last 3 years. A latest installation what we did, it was at Chandrapur district. Here the problem statement was, there was well, a perennial well you can say, a rising main was there, a ESR was there in a good condition. But the ESR was at the tail end of the village. So the part of the village which was elevated was deprived of water for last 10 to 12 years. People are not receiving water with sufficient pressure. So for coping it, household motors was one of the solution, and going deep around 5 to 6 feet down to fetch water, that was the coping mechanism. So instead of that, what we did through a CSR fund, we have been allocated a CSR fund, we did the field survey and we took a single tapping from the existing transmission network. As you can see, the space constraint also. In very less space, the shaft has been constructed there, and this was the results. Consumer testimony, as you can see, the lady is saying after 12 years she has been receiving water to the ground level. Earlier they used to fetch water from the below the ground, still the water was not available.
आपण शाफ्ट बसवल्यापासून तर सगळे आता तुमचे प्रश्न सुटलेले पाण्याचे, तुम्हाला पाणी भरपूर मिळतं. असंच नेहमी आला पाहिजे. हो, असंच पाणी येईल. आता तुमच्या समोर आहे बघा, समोर लागल्यामुळे तुम्हाला दिसेल. ओके. खूप मेहनत झाली रामाने, पाणी सारे पुष्कळ 12 महिने हात पंपाचंच पाणी पावसाळ्यात.
Such kind of consumer feedback we get. So what happens, the major thing is the reliability. Females are the ones who fetch water daily, that's their duty as per our societal norms. Females are the ones who fetch water for the family. So if we provide a reliable water to them for next, suppose today I gave for 6 to 7 p.m. and next day we assured 6 to 7 p.m. with a good pressure, so they can plan their day accordingly. So that these are multiple benefits. Again, in Kagal part, there was a rising main. Another problem is we directly connect the distribution main from the rising main. This was the GSR which was bypassed, so direct pumping was there. Kolhapur is a water-rich district. There is no problem of availability of water. The issue was the management of water. So they used to fetch from a rising main directly connecting to the distribution main. Again, that resulted into a huge operation and maintenance cost. Moreover, tail end consumers were not receiving water. So instead of that direct rising main, we took the rising main to this shaft. As you can see, and what we observed due to increment in the pressure, the pumping time reduced from 75 minutes to 30 minutes. So on the part of energy savings, it can be beneficial. Similar was the observation in Boisar Dandi. Here, not a single village, not a single household is without Tullu pumps. Everybody is having the Tullu pumps at their households. There also his shaft is working fine. So these are typical what we propose. If you have then some people might argue there is an electricity issue in the rural part. So agreed, we agree for that. So we can use a small grid solar pumping station, solar pumps, which can be fetched to this shaft, and through this shaft we can distribute for small villages in the good pressures. Similarly, this was installed in an irrigation project. The problem statement here was there was a percolation lake available in Murbad district, Khewari village, and they were supposed to irrigate around 100 acres of land through drip irrigation and small tanks. So one of the NGOs approached us and they were planning to construct a ESR near the percolation lake. So the plan was to pump the water into the ESR and then to distribute. So instead of an ESR, we proposed a shaft, and the remaining amount which was saved from the ESR cost to the shaft cost, we went for the solar pumping. So it's a solar based pump shaft. Again, this one working for 1.5 years. So that time it was good results. So overall what we can say, since it's open to atmosphere, the air entrapment, which is the major problem in the water supply system, since it's a pressurized system, air entrapment should not be there. Once the air is entrapped, the complete hydraulics gets disturbed. So since it's open to atmosphere, the air entrapment nullifies. It's a multiple outlet, so you can create isolations. The HGL varies as per the demand. Since the diameter of the shaft is very less, so it's very effective. It's very adaptive to the consumer demand. If the consumer fetching huge demand, so HGL will reduce and so on. Less movable pots, so operational maintenance is less, way cheaper than a typical ESR, and the cost can be utilized for some other purpose like solar pump or basic automations. And moreover, the space constraint, like we have been hearing Jal Jeevan Mission for last 1.5 years, we have been visiting multiple clients, so they are facing the same problem. Land for an ESR. Although the DPRs are there, everything is there, but at the time of implementation, the ESR land is very crucial and they are not able to fetch the lands. So there this kind of shaft can improve. Moreover, as I showed, the consumer satisfaction, to break the vicious cycle, the consumer satisfaction is a very vital component, which can be achieved through these shafts. Again, you might be saying it has to be a pressurized system, direct pumping. It can be utilized in a combination of an existing ESR as well in an urban or semi-urban context also. Basically, as we discussed, this is a ESRs and this is a typical operation. We operate this wall, we give water to this subzone, then it's turned off, and so on and so forth. That's a general practice, a prevailing practice. This results in, as I discussed, inequity. The people residing near to the consumer, near to the ESR, will get sufficient amount of water. The tail end consumers are always deprived. So there are a number of problems they have to face. Sometimes the ESRs are bypassed. So what we are suggesting, you can, instead of such kind of practice, you can construct a shaft at an appropriate location at the downstream of an ESR. So for that, the location for that, there has to be a multiple cycle, what should be the height, what should be the diameter, what should be the location. It has to be scientifically decided, but just for a concept, it has to be below the ESRs, and a specific express feeder can be given to the shaft. And from the shaft, you can, without changing your distribution network, you can create separate isolations. That will help to achieve the hydraulic grade line nearer to the consumers using this shaft to achieve equity in the system. And to this, we have termed it as zonal storage with hydraulic isolation structures. So this can be utilized at multiple locations. And the next major problem is with the transmission networks. I will show this with how a manifold works. I will show this with the animation. This is a typical transmission network. In the design, what it is supposed to, the MBR, through the MBR, all the ESRs the elevated storage tanks are supposed to be filled at a time. That's what design is meant, and that's how the construction is done. But due to the standing water column or flow start condition at the outlet of the MBRs, we can't fill the ESR at a time, so we go for staggering each ESR at a time, which results in emptying and refilling of the larger transmission networks. The transmission network diameter is huge, so you can anticipate what should be the volume of water every time we have to refill. So instead of that, what we are suggesting, a manifold is a typically drum and pipe arrangement, wall and pipe arrangement, not very complicated. Two drums, a first drum, it should be pressurized completely, At the drum, there should be a pressure gauge and an air wall. Once the air is completely released and the system is pressurized, the drum 1, you can operate the intermediate valves and fill the second drum, the drum 2. Mind you, the pressure gauge reading should be same for the drum 1 and drum 2. That time you can be assured that system has been stabilized completely. Once that is stabilized, you can operate the outlets so that the system can be pressurized completely. To increase the flow, the walls which are given at the middle between connecting walls between drum 2 and drum 1 can be operated to increase the flow, but the pressure has to be same for both the drums. The system cannot be disturbed. Once this is achieved, the system will be completely pressurized. And how this will sorry for the disturbance. I will show the case studies directly. So this was first implemented in West Bengal. How the manifold can improve the systems. The chief engineer was there, the whole team was there to identify the problems. This was one of the areas in West Bengal. As you can see, the ESR is good condition. It's a 21 meter staging height with 3 meter depth. Everything is good. The system looks good, but the problem in the system was within 100 meters of the distance from the ESR, there was around 10 to 12 meters of head loss. And that we have understood through our complete pressure measurement. This was the serving area in the left side. As you can see, it's a huge serving area. And we have measured pressure at different points, around 30 to 40 points where we have understood and allocated. And for that, we did the pressure measurement. What we understood, after this 100 meters, there was a reading of around 10 meters. 10 meters the pressure gauge was showing, which should have been more than 20 meters. And this P1, P2, P3, only 3 points were showing some pressure readings. The other points were not having good, they were showing 0 reading. That means water was not going to the tail end consumers. So these were their coping mechanism. Instead of a electrically operated motor, this was the handheld pumping, what they used to do. So to improve the system, we installed such kind of manifold at the bottom of the ESR. The inlet to the manifold was directly connected. The inlet was from the outlet of a ESR, existing ESR, which was directly connected to the manifold. The diameter of the manifold was 1 meter and the length was 6 meters. And we provided multiple outlets. As we explained the benefits of the multiple outlets, to convert the existing single outlet, this can be one of the strategies to achieve multiple outlets. In the drum, as you can see, we installed an air wall. So once the air wall released, we achieved a pressure of 2.1 kg at the manifold. Sorry, okay, I will cover it. So this was the scenario. I will show you pictorially, that will be more impactful. Earlier, this was the serving area of the OHR, a very light area. After manifold, it increased drastically. The PHAD was going for a new ESR and a new construction of an ESR and all that stuff. Instead of that, we install a small manifold with minimal cost at the bottom of the existing ESR, and such kind of result we have achieved. And this was even documented in Jal Jeevan Samvad recently. Similarly was achieved in Bhiwandi, Mankoli recently. Here, the water supply client was directly given from the air wall. They were directly giving water to the consumers. So there was, again, you can see at the left corner, that was the scenario. People were not receiving water with a good pressure. It was almost 0. Since and at the air wall, the pressure was around 7 kg. You can see from 7 kg to 0, that was the scenario. So to avoid this, what we did, instead of a direct tapping to this air wall, we took a inlet from the air wall. We installed a drum of appropriate diameter, and these 2 pipelines were connected to the existing line. We haven't touched the distribution line or the transmission line, just maintain the pressure at the source, and we achieved 14 meter of pressure increment at the households. And this was the scenario. This is the typical, you can see there is no ferrule. They directly pump from the tap itself. Still the system was performing. It's near to Mumbai only, not too far. Again, we are working in Dhanu. This will be completed soon. One last case study I will be explaining. Based on this all intervention, PhD West Bengal has given us a work to solve the biggest, one of the not so good performing scheme, Bali Chagaji existing water supply scheme. It's a huge scheme serving around 3 lakh people. It was around 400 crore scheme, constructed and commissioned around 2019. And after a couple of years, people were not receiving water. So that was the scenario, unfortunately. So what we did, these were the steps recommended by us. There was an issue at inflow only. The WTP, the inflow and the outflow was mismatched. There was a mismatch. That's why they have to turn on and turn off the transmission network and the pumps, which again created inequity in the transmission network itself. So second step was to maintain the pressures in the transmission network. Our approach is to at least the transmission network has to be, first step should be, it should be completely pressurized for 24/7. Then you can go for distribution network. And there was no proper zoning. Since West Bengal is relatively flat area, so it was haphazardly planned and directly zoning was not there. Then finally we suggested this shaft and manifold wherever needed. So this is a typical hydraulic modeling which I showed the method. We did applied in the transmission network, and again we validated with the field data, and it was more or less the same data. Field data was collected by PhD, the flows were collected by them, and through our modeling output we validated our modeling technique. This was the clusters we suggested them, such kind of clusters. Earlier there was not clusters. All 14 zones were given water simultaneously. For coming to the distribution network, there was a OHR, but there was no proper zoning. So what we suggested through manifolds and shafts, you can create separate isolations, such kind of isolations in the system, which will again improve the efficiency of the systems. And this work will be commenced in coming few months. To finish off, all these interventions are recommended by Ministry of Jal Shakti in 2020, and recently MERI, which is the nodal body of irrigation in Maharashtra, they have also recommended. Moreover, this has been patented by IIT Bombay, and I'm a part of that patent. And after my PhD, I have started this startup along with my supervisor. So this startup company has an exclusive right of this patent. So to summarize, our basic focus should be to understand the system. We are not saying everybody shaft will solve the problem or everywhere manifold will solve the problem. Our intention should be go on the ground, understand the system, do the field studies, do the hydraulic modeling. Based on that, you can provide recommendations. A one-fit solution for every scheme won't solve the problem. Again, the application of intervention should be on the operational hydraulics and then a gradual transition towards a continuous water supply system. Thank you.
You reached out of Maharashtra, then near close to Bombay and even within Maharashtra also, but you have not looked into Mumbai properly. I want you to see in Mumbai also. Just come here because some questions will be there. So, because this emptying reservoir we also faced during commissioning of this Virawali tunnel, and we thought that since tunnel is in place now within the, because we almost brought the Virawali reservoir from Virawali hills to almost into the Versova, and we thought that we can give the 24 hours water supply. And surprisingly, when we started the commissioned tunnel, within half an hour my reservoir was empty. So when we investigated, we saw that all those high-rise buildings were having booster pumps and very large connections designed for 2 hours supply or 1.5 hour supply. And when that tunnel was commissioned, it was at very high pressure and everything, and that reservoir got empty within half an hour. So we have again switched over to intermittent system only, whatever it was, even after commissioning of tunnel. So very good presentation with all these innovative ideas of multi-outlets and manifolds and pressure shafts, demand-driven network and all. So we would like to see these experiments done in some urban environment also, because most of these experiments are carried out in the say peri-urban or rural areas. Anyway, so a few questions if somebody.
I would like to give you one, based on my experience of maintaining water supply schemes, I would like to give you one more scenario. Like suppose for a given zone, if the total volume of water which can be contained in those networks is more than the capacity of the reservoir, probably then also we'll have flow starved condition. So will your manifold and shaft can tackle this issue? Because we have this issue in the urban sector as well as in the rural sector, wherein we have wadis and habitations which are almost 10 to 12 kilometers away from the village, and then we have to lay a very large network to cover those wadis. I think in that case also we have faced flow starved conditions. So will these two methods tackle over that problem?
Sure, ma'am. It has to be in a combination. First thing, if existing ESR is there without multiple outlets, so you have to install a manifold at the bottom so that the outlet pipe is pressurized. Moreover, the shaft at the tail ends has to be like proper after study. At the tail end consumers, as you have rightly said, some padas are away. For that, a separate hydraulic isolation structures like shaft can be installed. And with existing water supplies, moreover, the first thing what we have to do, ma'am, the demarcation of the hydraulic network has to be done properly, ma'am. If suppose the water is not available, then none of the techniques will work. If the hydraulic demarcation is there, and to isolate, such kind of techniques can be used, ma'am. Yeah, in West Bengal also, yeah. C value, based on the C value, we have to be discarded the pipes. So basically it varies from pipe to pipe. So for each values, it will vary. Definitely it will vary for pipe to pipe. For rehabilitation, there has to be a proper channel itself from C value, and we have to do multiple studies. There are multiple papers done internationally which suggest different numbers for C values. I can't recall each value, but there are multiple studies going on. What should be a C value and what should be the rehabilitation plans? That's
anyway, up to whatever level this serve your purpose, it is fine. Because in Mumbai also we have 100-year-old network is also there, and recent network is also there, and we are still having the old network also, which is 100 years old. We don't even know what is the C value of it. So as long as network is serving your issue, problem, it is good, we can say.
Chinmay, are you connected?
Yes, sir. I'm connected.
You can open your presentation, please.
Sorry, just a second, sir.
Our second speaker for this session is Mr. Chinmay Tripathi. He is an environment engineer with more than 20 years experience in water sector with significant national and international exposure. He has been working closely with the Government of India, various state governments in India, Government of Odisha in particular since last 10 years, and many bilateral agencies. He has diverse experience in managing the water and wastewater projects, and currently Mr. Tripathi is working as a resident project manager at VETCO. He is one of the governing board of members of Odisha Water Academy, a government of Odisha institution for capacity building as a sectoral expert. Mr. Tripathi has been also a key member for the Odisha drinks water from tap mission from concept to commissioning, and significantly contributed in bringing the policy reforms, institutional reforms, 24/7 water supply project formulation and implementation in several cities in Odisha. He will take us through the Odisha water sector's journey from water scarcity to water security in urban Odisha. Yeah, okay, Chinmay, just deliver your lecture.
I think Chinmay is not able to load, so I will load the presentation from this end. You are able to see this now? Chinmay, you are mute.
Good noon to all the delegates, the organizers. I thank IWWA to give me this opportunity to present. Today I will speak not only the hardcore modeling part, but it's basically a case study in Odisha, how we move from a water scarce situation to water security, and basically working on we worked our basics right. I will show you what kind of challenges we faced and how we moved on. Now from a water scarce situation in around 21 cities, we are providing 24/7 supply in 6 cities on the entire city manner, and in another 15 cities in partial manner. So my presentation will mostly focus on the policy to practice, how we are practicing now, and what are the policy changes we got in. So if I may request to next, please. Yeah. So, sir, I cannot see my presentation, so it would be better if I start sharing. Okay. So our Odisha was suffering from all the water supply challenges. We had very poor service and intermittent supply, providing maybe around a couple of hours in some areas 3-4 hours without any certainty. The water quality was always questioned with frequent jaundice and diarrhea outbreaks. We had absolutely no metering. Am I audible, Sunmanisa?
Yes, you are able to see the presentation on your screen?
No, I think I'm not able to share it on the screen.
No, you are able to see the presentation which we are showing.
Yeah, I'm able to see the presentation, yes.
Please go ahead.
Yeah. So we had no metering, absolutely, and the water loss, when we did the water audit, the water loss is around 54%. Even if we provided pipe coverage, even the house connection was very poor. Only 50% of the houses were connected, and there was a big gap between the community and the water supply authority. Nobody was, in a sense, talking to each other. Did not have the trust on each other, in a sense. So we understood that looking at the challenges, we understood that we have to first correct the basics. No, we cannot just go on building infrastructures without looking at the overall aspects. In addition to that, there was a huge inequity in supply. If you see the right bottom graph, in some cities, the per capita supply was 11 LPCD, whereas in some cities it was around 350 LPCD. Plus, within the city also, in a slum, people were maybe getting 20 LPCD, whereas in the post locality, they were getting 300 LPCD. So there was a huge disparity between the cities and even within the city. So with these basic challenges, we had the network coverage was also only 40%, so we could not reach to the people. Supply, there was a deficit of around 200 MLD deficit on a state level. So with all these basic challenges in 2015-16, we set and developed how to bring this drinking water to a better level. So from there, now we are. Can I go to the next slide, please? Now we are at, that was the situation in 2015-16. Now in 5-7 years time, of course, we put emphasis on our infrastructure augmentation and we laid around 8,000 kilometers of pipeline across the state to reach to every house. Our house connection that time was only 3 lakh. Now we are reaching the 1 million house connection. Our total connection is roughly 1 million if we see the urban population of Odisha. And as of now, out of 115 cities, in 105 cities, we have 100% house connection in every house has a piped water connection. So 98% of the households have a piped water connection. And our target is to reach 100% in all across the state. In 2020, we intentionally declared, Bhubaneswar with 169,000 house connections, we ensured that every house is connected, and we declared Bhubaneswar as the first million-plus city to have 100% house connection. After we achieved this house connection, we ensured the universal coverage. The next was to move to quality and equity. So we focused on 24/7 water supply. We call it drink from tap. And first we achieved in Puri in 2020, and now another 5 cities are provided with full 24/7 supply. And in 17 more cities, more than 150 DMAs, zones, are already commissioned, and the work is ongoing. And by end of next year, around 23 cities should have a full 24/7 water supply. So this journey from the precarious situation of water scarcity to this, where are we now, that I will be presenting today. And interestingly, previously, every time there was a PIL in the High Court regarding the water quality or the water supply, and in the Assembly also, there were many adjournment motions. But now, since last 3 years, we do not have any such instances. And the public health outbreaks, in last 2 years, no casualties have happened due to jaundice or diarrhea in the urban Odisha. Can I go to the next slide, please? So the first thing we focused, we said before going to 24/7 or many technology adaptations, we thought we must get hold of our basics. So we saw that our policy, our existing policy for giving water connection was very much, in a sense, prohibitive. Many times we wanted 14 types of documents for a connection, so people were not coming. They were very happy with an unauthorized connection rather. So looking at those issues, we took some policy reforms. So first thing we added in our water policy is that every citizen must have a right to tap water. So the government cannot deny tap water. Second thing, to reduce the non-revenue water, and before we went to the 24/7, we thought the hand pumps and public stand posts have to be eliminated, because when we are providing water to every household, the hand pumps and public stand posts need to be eliminated. So we eliminated now. And the house connection norms for the urban poor is fully relaxed. First thing, previously the slums, we were not providing any house connection, thinking they are unauthorized and they might be evicted. But then the policy was changed and said, because of the citizens' right to tap water policy, every person, even if he is staying in a slum, we must provide water supply. That was the policy change we brought. And initially for the connection fee, whatever 3,000 rupees we were charging, that we waived off for the urban poor. And besides some installment payments for the other charges. And another big change we made previously, the consumer has to submit an application and they have to actually execute the house connection work. But now we've changed it that the government has to execute the house connection. Because, you know, by allowing the untrained plumber appointed by the consumer to puncture my system, I'm actually putting my entire asset at risk. So looking at that cost benefit analysis, we thought it is better that the government, the water supply authority takes care of the house connection. So this was a change. Now the consumers need not go to any municipality for a road cutting permission or anything. They simply give the application, and the application also they don't have to come to office. It's a doorstep service. So people will go to their doorstep, collect the application and give the connection. Then secondly, by that they actually got the waiver of around 10,000 rupees for the road restoration, road cutting permissions and all of that formalities. Lastly, we changed, there were 14 documents were required. We changed to 2 documents, just the Aadhaar card and an indemnity bond, because our people said that there are risks that they might claim the unauthorized property as their land because of the water supply connection. To cut down, to mitigate all those assumptions, we took an indemnity bond that the water supply connection, the water supply authority is indemnified of any litigations. Then my previous speaker said, the women are the main water fetchers for every home. So we involved the local women self-help group for the 100% tap for the doorstep services. We did not have to hire people to do it, but we took the local women's help. So these are the policy changes we made. Next, please, sir. Next slide, please. Yeah. So with the women self-help group, this was a first of kind thing we did. Odisha had a very good network of women self-help groups. So we appointed them at Jal Sathis. So for every Jal Sathi, we gave a jurisdiction of a ward covering roughly around 400 households. So they were acting as a bridge between the agency and the community. Now these Jal Sathis, we fixed up an incentive plan that if they get a new connection, they will get 100 rupees in incentive. If they convert an illegal connection into authorized connection, they would get 200 rupees. And if they get a commercial connection, they will get 300 rupees. And for every month, meter reading and bill collection, they will get 5% as their incentive. So with that, every Jal Sathi these days are earning around between 10 to 50,000 per month. And we have 800 such Jal Sathis across the state. You know, without doing a single government appointment, we have a large brigade of workforce for the doorstep services. And now the roles and responsibilities are, sir, next slide, please. And the roles are basically reading water meters, generating bills, collecting water user charges, the field water quality testing, because you know, our challenge was to ensure quality at the consumer end. We had good surveillance mechanism at the bulk supply or even at the WTP or at the ESR level. But at the consumer end, we had to train these Jal Sathis to make some indicative tests at the household level also. Lastly, the facilitating consumer redressal, because sometimes the raw feedbacks of the consumer, they never called to any helpline number or anything, but through them actually we got a lot of complaints and the feedbacks, and they are these Jal Sathis would run after us, the WATCO, to resolve these issues, because next month they have to go to the house to collect the bill and so they have to maintain their repo. So the consumer complaint redressal was also very well facilitated by these rules. So likewise, in every ULB we have, for Bhubaneswar we have around 80 Jalsatis, for Puri we have 35 Jalsatis, like that we have around 800 Jalsatis across the state. Now to increase their revenue collection, we have also introduced a unified revenue collection mechanism where now they are also collecting the property tax. So please, next slide please. So if you see this slide, the property tax, if you before and after the induction in 2022-23, our water supply revenue collection went up from 69% to 97%, and at the same time, the property tax collection is also went up from 57% to 75%. So these community partners, because they are our performance-linked incentive-based partners. After that, there was a sea change in the customer relationship, and achieving 100% house connections and also eliminating all the illegal connections, they played a very pivotal role in that. So next slide, please, sir. Now, in addition to address an inclusivity, we have also inducted some the transgender group members. They are maintaining, because there are many qualified transgender members are there, they are maintaining some of our WTPs in Cuttack and water kiosks, drinking water kiosks, wherever they are maintaining. So the vulnerable communities, we wanted to ensure a 360-degree community participation. So all the vulnerable communities are also taken on board. Next slide, please, sir. So with these community partners, we moved from 3.1 lakh connections to now nearly 1 million connections. And like I said, out of 115 cities, in 105 cities, we have 100% house connection. And we had no metering. Now we are moving towards 100% metering, and around 4.62 lakh meters have been installed. So we are roughly at 50% level in metering, and maybe by middle of next year we should achieve the 100% metering. Next slide, please, sir. What I, when I say our 105 cities are 100% house connected, we deliberately declare each city as 100% connected, because by that there is a huge responsibility on the divisional engineer to maintain the 100% house connection level at all times. And we create a committee with the collector's representative, the urban local body, councillor or corporator, the urban local body, executive officer's representative, the WATCO and Jalsati. They issue a certificate kind of thing. They survey every house and issue a certificate that these many connections and 100% connection is already completed in the city. So with this certificate, first the executive engineer issues a tweet, followed by the engineering chief, up to the chief minister's office. It is declared that the city is 100% connected. If some house is not connected, they may come back within a week and we will connect to them. So this is a process we introduced to bring in accountability in the system, because when it is declared right at the CM's office, nobody will bluff on the number of connections or the so to ensure the 100% connection, we introduced this declaration mechanism from the bottom to the top. It is declared, and every time we are on our toes to keep it 100% connected. Next slide, please. From after we ensured universal coverage, now that our 105 cities out of 115 are covered, we move to the 24/7 water supply. Whenever we talked about 24/7 water supply, there was a huge misnomer, especially in the general public or the political scenario, that the 24/7 supply means more water, more losses. Where will we get so much water? So we understood, instead of using that engineering term of 24/7 or continuous water supply, why 24/7 water supply? Basically aiming at the quality and equity. So we named it drink from tap. We said that if we provide you 24/7 water supply with other measures, you can directly drink from tap. plus every slum households, you know, the main beneficiary of this 24/7 water supplies are slum households. First of all, our priority was to cover all the vulnerable urban poor sector, because many middle class or the upper class people already have a overhead tank and they anyway get 24/7 water supply. They don't understand the quality contamination part, but they store water and they fetch 24/7. So the main beneficiaries are the urban poor. So we thought that we must do it in all the slums, and if we are successful, then we move to the entire city. So we made the slum people understand that you need not store water, you need not buy water, you need not wait in the queue to get water. So you will get 24/7 water. So we started piloting it in slums. The biggest slum of, can you move to the next slide, sir? The biggest slum in Odisha is Salia Sahi, one of the biggest slum, which has got around 59,000 population. There we first implemented it to even a thatched house with a piped connection and 24/7 water supply back in 2020. Next slide, please. Then we moved to city level. In Puri, we first implemented for the entire city with 33,017 connections at that point of time. And we ensured IS 10,500 water supply to every house. By that, because of the community partnership, our revenue collection was increased to 97%. The water losses in Puri were previously audited to be 47%, and now we are consistently below 15%. And for the first time on a city level, we implemented a smart water management, the IoT-based water supply monitoring. The flow, pressure, all of that is being monitored on a real-time basis. It's not only monitoring, but it's also command and control. So this also we implemented in Puri, which I'll tell you in detail in my later slides. Next slide, please, sir. Here we went to the basic approach of 24/7. The DMA concept planning was made, which was previously not there. We hardly knew what was the infrastructure, so infrastructure condition assessment was key. Fortunately for Odisha, majority of the water supply infrastructure were fairly new, mostly with JNNURM or UIDSS SMT time, so 5-10 years older. So we mapped all the consumers and the assets on GIS platform. Then the gap closing thing, 100% replacement of existing house connections, because we understood that the ferrule connection at the household level, if that is the most potential leaking point. Sometimes whenever we talk about NRW, we focus on the transmission mains where the big water is lost. But if you see every house connection, because of the imperfect connection, drop by drop water trickles down. And all those connections were replaced with a compression and saddle fitting. Then we implemented 100% water metering and IoT-based digital water management. And with this, we approached 24/7. Next. Every DMA, we took mostly 500 to 3,000 customers based on the existing system to make it discrete with a zero pressure test. And in some cases, even if there is a 3,000 customer DMA, we further subdivided into sub DMAs to make it more operation friendly. Next slide, please, sir. Next slide, please, sir. Is it moving? Okay. So all our assets we mapped in GIS platform, all our consumers with the KYC, the know your customer format, not only the consumer address, but all the demographic information along with their billing, all are automated. So we can see we go to every house and we know what was his past billing, how much area is there. So the GIS-based consumer and asset mapping was our first step that we did. And the next slide, sir. Then we basically went into the IoT-based smart water management at the ESR level, treated water transmission main, water meters, the DMA and sub-DMA level. And at the farthest end of network, we have also introduced a residual chlorine analyzer, which transmits data at every 5-second interval to our server. and operation of DG sets, pumps, all of them were connected to optical fiber networks to our main server. So we collect data basically every 5 seconds from every place, and we monitor the supply. Next slide, please. You see in this picture, even if there is one DMA, first we structured one DMA with 3,000 customers, but then to better manage it, we divide it into sub-DMAs, and from one ESR, we have bifurcated the line into 3 sub-DMAs, and we have pressure transducers, differential control valves, and electromagnetic flow meters are installed in every sub-DMA supply lines to manage the flow and pressure for every sub-DMA. Next slide, please, sir. Because we get the data at every 5 second interval, we have installed around at 140 places terminal devices in the network from which we get the continuous flow and pressure data. Wherever there is a burst or there is a leak, we get you can see the bottom graph, there is a gap in the pressure where the red line drops. It means there is a break or there is a repair work going on and there is a pipe burst, so the pressure dropped. So we could see how much time it took us to repair to get the pressure back to normal. So that also our operational efficiency we were able to manage. And for every DMA, we have this kind of dashboard which shows us pressure, flow, and the quantity of supply at every hourly basis. With which basically our issue resolution time has reduced from days to hours, and the non-revenue water, because we could efficiently manage the leakages, our non-revenue water also reduced to less than 15%. Next slide, please, sir. It is mobile. Every engineer in their mobile phone also has the app. For every DMA, they get all the data of the pressure. Wherever there is a pressure drop, they get an alert. And based on our bulk water meters at every sub-DMA level and lane level, we get the non-revenue water in real-time basis. Though it is a very subjective non-revenue water thing, there might be losses between the bulk meter into the consumer meters, which we assess on a monthly basis. But from the WTP up to the supply of the lane level or the sub-DMA level, all those meters provide data on real-time basis, and we get the non-revenue water of the losses in between. Next slide, please, sir. We have we only do not see the data. From the application, we can actually command and control also. We can increase the pressure, we can switch on and off the pumps, and we have a command and control center where our people are sitting. The moment they get a complaint or they see there is a pipe burst happened or a pressure dropped somewhere, they immediately inform the crew. We call them quick response team. So they go to the site and immediately repair the leakages. Next slide, please, sir. So we have a 24/7 customer service center, which is IVRS based, and whenever we get a call, the call may be from the integrated command and control center also. So they will assign to this quick response team, which are 24/7. They are provided with a dedicated vehicle and tools and tackles. Not necessarily they can immediately resolve or repair the leakage or the repair the defect. But whenever a customer calls and they are at the site, the consumer confidence increases, and they stay there until we repair, or they give information to the consumer when the spare parts are coming and when the repair work will be completed. Next slide, please, sir. So, when we move to drink from tap, when we call it drink from tap, we all are basically put our heads on the sword. Because anybody if complains that the water is not drinkable quality, somebody's head will roll in our system. So water quality at every consumer step is our priority. So the water quality we are monitoring in four-pronged strategy. One is we have got NABL accredited laboratories which do more than 69 parameters test on a routine manner. Then we have residual chlorine analyzers at the farthest end of the network, which provide us real-time data so that the chlorine dosing automatically happens without any manual intervention until we reach 0.4 ppm in the system. So at least the coliforms are not there. Then we have deployed lab in wheels in every city. So whenever a consumer complains or a repair work is completed, this lab on wheel goes there to check the basic parameters before we resume the supply. And also it gives consumer confidence. Whenever a consumer has a complaint, we go to the residence and take this lab on wheel can take 14 parameters can be tested on this. Plus the Jal Sathis, whenever they go to collect the water bill, they are provided with a small water quality test kit wherein they can check couple of residual chlorine and some indicative water quality test at the consumer level. Next slide, please, sir.
3 to 4 minutes, Chinmay.
Yes. So then we understood that the consumer trust and confidence was also very important. So like air quality data is displayed in many parts of the city, we started displaying the water quality data at every DMA whenever we give 24/7 supply, so that the people see that the water quality is up to the mark and I can drink it directly from the tap. So we ran a campaign called Pure for Sure campaign. These public LED public display boards were installed. Next slide, please, sir. Now, when we talk about plumbers, house connections, if I send untrained plumbers, they damage our asset. So we created an empanelment of plumbers. Those plumbers can only go for repair of house connections or to provide a new connection. So the plumber training and certification has undergone, and we've empaneled many plumbers. Plus, we've created a non-revenue water reduction cell, which we have institutionalized with the executive engineer heading it, with it's a 8 to 10 member team whose only job is to identify leak and repair and monitor non-revenue water. Next slide, please. As a part of institutional reform, we understood that to bring in the customer service-centric culture, we no more can function in the regular way. So we created a company called Water Corporation of Odisha, water company, to provide water and sewerage services. This company was formed in 2000. It's a government of Odisha company with majority of the shares of governor of Odisha. It was started operating in 2018 and with 3 cities, and now in 2022-23, 29 cities are there. But with these 29 cities, around 65% of the urban customers are handled by Watco. And last year, it won the Global Water Leaders Award for the innovations and speedy execution of many reform activities. Next, sir. Now this 24/7 water supply, we did not stop at Puri, but the challenge was to upscale across the state. We are now implementing in 23 cities, and in 21 cities, around 18 lakh population is already benefited by commission. We've commissioned it around 150 DMAs, and in 6 cities we're fully covered with 24/7 supply. Next, sir. There are the challenges. Previously we did not have any information on the existing infrastructure of customers. We did the GIS-based asset consumer mapping, which I showed you. So this was the solution. People were registering for 100% house connection and metering. So we put out this community partnership model where the local ladies can go into anybody's house and convert them to unauthorized to authorized and market them to get the connection done without any hassles. And the water quality, ensuring water quality at the consumer end was always a challenge, because we can always ensure it at the WTP level or the bulk supply level, but at the consumer it was a challenge. But I told you how in the 4-pronged strategy we monitor the quality. And lack of enough staff, the knowledge of 24/7, or even finding a contractor. Whenever we tried to find a contractor, is always a big shots were coming, and we could not. So we had to train the local contractors, local resources to execute it ourselves. Next slide, please, sir. Another A couple of challenges was the lack of public confidence. We displayed the LED boards, the non-revenue water, we institutionalized the non-revenue water cell, and we created standard operating procedures for everything, for operation maintenance of intake, WTP, house connection, everything we created standard operating procedures. Next, sir. Now, with the status of the service level benchmarks, except for the operational cost recovery, which we have not reached yet, all others are as per the national benchmarks. Next, sir. We did a impact assessment study by a third party, NIUA, and whether really people are drinking directly from tap or not. And this was a study of around 3,000 respondents. Around 88% in Puri are drinking directly from tap. And I'll tell you, around more than 25% of the households have actually eliminated the overhead reservoir or household level overhead reservoir or the daily sucking of water from our system, underground sumps. So, but every day we are marketing to convincing them to remove it. Next, sir. The bottom line, I'm coming to the end. The bottom line is, I told you the jaundice and diarrhea outbreaks when we had 29 deaths, jaundice-related deaths, and 30 deaths with around 4,000 cases in 2015. If you see 2019, 20, 21, when we started giving 100% house connection, the real result in terms of the jaundice and diarrhea could be seen. No fatality and very few cases. It just dropped significantly. And this is a data from our health department integrated disease surveillance program. Next slide, please, sir. With Ministry of Housing and Urban Affairs have published a case study which is Drink from Tap mission in Puri city, which gives all our lessons learned and which we can actually go through. It's available online. Next slide, sir. And we created a Odisha Water Academy basically to train starting from plumbers to policymakers, plumbers, operators, supervisors, engineers, managers to public policymakers on the 24/7 water supply. We have trained around 2,400 people with 70 international delegates from Bangladesh, Nepal, Sri Lanka and many places on the 24/7 water supply. So 3-day, 4-day, 5-day courses are there. Next slide, please, sir. These are our way forward. Our objective is to bring down the NRW to less than 10% and to provide 24/7 supply in all our 115 ULBs, and we want to get into the AI enabled IoT in all our cities, and climate smart water supply systems we have to build because Odisha is very prone to disasters and cyclones. So this is our objective. And NABL accredited labs in all 30 districts. We have 8 laboratories, but we want to put it up in all the 30 districts to better check of the quality. Next slide, sir. So the key takeaways are, what we understood, public drinking water supplies, as long as we deal it as a purely engineering issue between the engineer and the contractor, then we can never build a sustainable system. So we thought it is mostly until we took the society or the community on board, we could not sustain it. That's why many places we provided 24/7, but after few months it became unstable. So the policies are to be rewritten whenever it is required to make it customer friendly. The community onboarding is very key. The continuous technology orientation and skilling of the staff and speed in decision making and leadership is very key in the implementation of this kind of reform oriented schemes. Next slide, please, sir. With this, I thank you for any questions. Because of the time paucity, I have my speed of saying might be a little fast. So if I miss something, kindly I am available for any questions. Thank you, sir.
Thank you, Chinmay. You've done a very great work in the Odisha. Anyway, there are, as you said, that most of this network is new, so we cannot reach on the any. It will take a little more time for us to convince with that it's success of this entire endeavor. But few things are really very good, because that making the connection process easier, and then making it less, then document requires for connections less, then that your Jal Sathi concept, these are really very good and implementable by the other utilities also. Then your tax collection improved from 69 to 27% is also a very commendable achievement actually. Okay, so if any questions are there, it is open for audience.
Yeah, Chinmay, this is Chinmay, this is Palande, Chief Engineer WSSD from Maharashtra.
Good afternoon.
At the outset, I would like to congratulate Odisha team for coming up with such a beautiful work, so systematic and so meticulously planned, and you have achieved a great feat, no doubt about that. I just had few small queries. The first is because we all know that Bhubaneswar and Puri are very old cities. So just for my understanding, I wanted to know if those households had underground storage. First question. Second is, what was the cost of production of water in Bhubaneswar before implementation of 24/7, and what is the cost of production now after implementation of 24/7? Third, what is the terminal criteria for maintaining terminal pressures in the distribution network in Bhubaneswar?
Okay. So the first question, ma'am, we had whenever there was no DMA concept previously, so we had our elevated service reservoirs or underground reservoirs at some locations. But the moment we structured the DMAs, we had to construct additional ESRs, and somewhere we had to abandon our UGRs a DMA basis. So that we came up with additional storage facilities, and previously also our ESRs may be more than required capacity, but we are still maintaining them, and we are controlling the storage with the automatic valves. The next question is the cost of production. Previously, our cost of production was around 18 to 19 rupees based on our calculation, and our tariff is merely 5 rupees 40 paise per kiloliter, and for the commercial we are collecting around 13 rupees. We have not touched on the tariff as yet, because our focus was to improve the service first, because when we increase tariff then people start resenting, so we wanted to establish the service standards first, and after doing 24/7, the production cost has neither increased much neither decreased much, because we could control our non-revenue water significantly from 47% to 15%. So our production has actually decreased. With the lesser water we can provide to more people. So the production cost still remains at the 18-19 rupees as of now, because we have not done any fancy treatment or anything. The same treatment processes are there, only we have increased our surveillance mechanism and the contamination en route. So the production cost has neither increased nor decreased, but still we are now, because we are working for rationalizing the tariff, We are doing a fresh assessment of our production cost. I do not have the absolute figure as of now. But there is no drastic change in at least the expenditure or on the production. Then the residual head at all our objective was to provide water up to the third story building. So we have maintained a 17-meter head at Puri, and in Bhubaneswar also the same head we are maintaining. Though CPHU has recently recommended for 21-meter head, we are going in because in some of our cities, Odisha's urban setups are very small at times, so we do not have 4 or 5 story buildings. 70-80% of their buildings are less than two floors, so we are still going for 15 to 17-meter head in all our cities.
How do you maintain 17 meters head in the distribution network?
But sorry, ma'am.
How do you maintain 17 meters head in the distribution network? Because
because we by pressure management, we have the pressure controlling valves at strategic locations. So whenever there is a pressure drop, we use boosters, and we maintain the pressure at up to the far end of the network.
Thank you.
One of the question was for ma'am was whether there are storage tanks are there. Sumps are there or not in the individual buildings.
In the storage, okay. Sir, every household has a underground sump or a overground storage. So, and daily pumping is also there. So the sucking from our system still continues. Unfortunately, we do not have a tank cleaning policy as yet. So we are not sure whether people are cleaning their tanks or not. So whenever we provide a connection, we convince the consumer to eliminate the underground sumps and the overhead storage. But it's very difficult to bring in confidence in the people's mind. In Puri, out of 33,000 households, till date around 8,500 households, we could eliminate the overhead storages and underground sumps, and they are completely now using the continuous supply. And to demonstrate, including all the government quarters, including the Secretariat and Chief Minister's office, we have eliminated all the storages, and we are feeding by direct supply, just to get the confidence percolated down to the public. But it's a long road ahead, sir, to eliminate all the 100% storages. But
my name is Pandit. My question is about the service storage that you have in the distribution system. How much is the service storage as compared to the total demand?
1/3 storage we take.
That is 33%.
Yes.
Of the demand.
Yes, sir.
Okay.
So, thank you very much for your very nice presentation. I would request my next presenter, Dr.
Thank you, sir.
Shailendra Singh Solanki. I will just briefly introduce him. Dr. Solanki has over 27 years experience, 17 years with the leading engineering consulting companies in urban sector. He has extensive portfolio of sustainable design service in wet infrastructure, prioritizing SDG 6 in majority of water solutions. Currently, leading infrastructure services vertical includes water, wastewater, stormwater, flood, rainwater harvesting, irrigation, electrical and energy, master planning and landscape designing. As Senior Vice President Infrastructure at EcoFirst Service Limited, a Tata Enterprises and 100% subsidiary of Tata Consulting Engineering in Mumbai, India. He achieved Doctor of Philosophy in Faculty of Science titled Resource Assessment for Sustainable Development Planning in Rajasthan State, a study based on GIS after completing Master's degree in Water Resources Engineering and Bachelor's degree in Civil Engineering. Gained professional skills set in working on GIS software, ArcInfo and MapInfo on the live project, and completed a certified training in geographical information system on ArcInfo software. In most of the project, to the best possible extent, utilize the space data and GIS-based tools in topography, hydrological and hydrogeological analysis of the project sites and its surrounding areas to ascertain available water resources potential in planning and designing sustainable water supply and management solutions for the proposed development. Welcome, Dr. Solanki. Please take.
Thank you, sir. Thank you, IWWA and Sonwani sir, for inviting me for delivering some information about sustainable water management through geographical information system. So it has been a long time for me for delivering a presentation on technical part of GIS, although my PhD was based on this particular subject only. So this particular picture, if you see, is a picture of the Kargil city. So when we initiated our working on this particular site, so it was quite challenging and very beautiful site, very challenging. And there we could experiment with all kind of GIS tools, technologies and working, which includes what Chinmay mentioned earlier in his presentation, that local support is very, very important in all kind of services that we generally design. We can design anything from the engineering point of view, but the local acceptance and its true representation on the ground is very critical. So for the simplicity, I had divided my current presentation in 3 categories. One is an introduction about the geographical information system. Generally, we know that only Google Earth and the Google Map that we generally observe in our day-to-day life is the only GIS, but it is not the same. It has many, many features which we should be knowing about it, and then we can do wonders in our design and planning. Second aspect, I thought that I should be discussing about the water. We generally all know about it, but there are certain things which we need to rebrush so that we identify the opportunities which are there in our as a technocrat planning and designing. Third, how GIS can give the opportunity in overall water management. I will say, since we aim for sustainability, we have to see what kind of opportunities we can have using the GIS. So we have covered that part as well. Yes, for me, when this topic was introduced, that GIS in water resources or water supply system, so nowadays it has become just like a salt in your food, that you can't separate it out actually. It starts with the data and it ends with the presentations or the graphics that you generally create out of your working in terms of any design, drawings, right? So coming back to the subject, that a geographical information system or geographic information system both means together as a GIS. It refers to a system where you are using computer-based tools and methods and you are integrating spatial data. Spatial data means that what is truly representing the Earth's surface. You are actually mimicking the Earth in your system by collecting information in terms of imageries and then digitizing it, getting it suitable for your say different software generally we used. So if we go by the word G means geography, which is the real word in terms like our Earth. I means information, which is data, which is which is the main bone of the overall GIS system. And then we read a system, which means that computer technology should be there, software should be there, and there is all supported infrastructure should also be there. So now when we say GIS, so when GIS terminology came into existence? So it came in 1950s, but the first GIS software was say developed by ESRI, which is still there, and we generally use the software as ArcInfo, and it is developed by the ESRI company. Canada was the first say nation to adopt GIS, and they did a really good say advancement during 1960s. And now with the evolution of GIS, and we are using say a lot of tools like GPS, which is now quite common, and Ola, Uber, they use quite often. They are based on this particular technology only. So there is a vast applications, and similarly the application is translating into the water and water resources subject. GIS itself consists of 5 elements, basically data acquisitions. So it requires data to be collected and then making it suitable for application. Pre-processing is done. So pre-processing is generally filtering the data and then make it usable to say bring it to the same datum. So we'll discuss about the data. So data is captured and then it is processed to make it usable. Formats are also there. Sometimes it is coming as a JPG image files or TIFF image files that need to be say converted into the same platform and used in the form of acceptable format in the system. Then data management, that all the data need to be say analyzed, collected and stored. And that stored data is further manipulated for different kind of analysis, and then product is generated. Now coming to the components, so we require computer hardware for say doing all kind of analysis. So it's a hardware kind of thing where we have to have say digitizers. Earlier digitizers were used. Now we have say auto digitizer, you scan and then the image is converted from raster to vector immediately through softwares. We had plotters in our times, the large plotters which still exist. Computer is the say the main system, and then output is generated into the printer. Then we have the GIS software. Many GIS softwares have evolved after ESRI, MapInfo, and then QGIS is a freely available software. Then there are say open platform softwares also available. Depending upon the applications, those softwares have been utilized. Now the important thing is where hardware and GIS softwares, they are static one. We need to have a dynamic interface. The human beings and the analysis done by engineers, operators, planners. So those operations are very important because that data is actually used for different kind of analysis and applications. Now when we say what kind of things can be done using GIS, so we can say categorize those operations in say 1, 2, 3, 4, 5, 6 categories particularly. We can say classify operations. So all the data which is collected and fed into the system and created as a database can be classified according to our requirement and application that we are looking at. Then we have scalar operations. So those scalar operations are primarily done to create one level of analysis using one single value. Then we have overlay operations. Overlay operation consists of one or more layers put together and then doing some analysis. Then we have connectivity operations that we want to connect raster to vector, vector to raster, or vector to vector. Those kind of operations can be performed by GIS softwares. Then neighborhood operations. What is basically that if we are having any point of reference or so point of focus, and we want to see how it is being say spreading or impacting, then we can create neighborhood analysis and generate certain outcomes. And finally the programming. So the beauty of this overall say GIS system is that you can create certain programs. In ArcInfo, AML language is generally used. So similarly other software uses different say programmings, and with those programmings you can automate some of the operations of the GIS system. So we can see that there are say different layers, and those layers are either generated from the real world or can replicate the real world situations in the computer system. And the advantage of GIS, we can say that it can do queries analysis. You can have different queries, you can run those queries, you do analysis, and then based on that you can generate the outcome. So that generation of outcome can actually improve the organizational integration. When we are serving or in the service industry, you can generate a lot of results in a very short time period. You will have better decisions capabilities. You can generate not only the beautiful maps, but those are factual maps which will be representing and giving the kind of solution that we are aiming at. So now, after this introduction about the GIS, I would like to touch upon certain important parameters and facts about the water. So when we say water, so physically we can observe that it's a transparent, tasteless, and nearly colorless chemical substance, but it has very, very critical importances. A lot of civilizations existed near the waters, and then with the deficiency of the water, those disappeared in historical time. And we can see plenty of water is available. So Earth is called as a blue planet because 97% of the Earth's surface is covered by water, but still we have very limited fresh water, and we are often encountering a lot of situations or water stress. You can see the water stress map where we can find that yes, there are blue spaces, but there are dark spaces as well on the global thing. And so see, no new water means we drink the same water that was existing during dinosaur period. So there is no as such generation. It is transferring from one stage to another stage. And with every year we are adding more population, not only human beings, but also the other population, animals and other biodiversity and other things which are increasing. So day by day water demand is increasing. And we can see that yes, we have a lot of green and blue spaces in India, but water stress is increasing day by day. Now, coming to an important aspect which I would like to devote some time here. So when we say cumulative socio-political drivers, so what is required? First thing which comes into mind, okay, we need water supply. Okay, so water supply, access should be there, security or in terms of confidence and safety. So all those things are required for the water supply to make the city well served. And a lot of emphasis have been given by the government of India also, where they are saying that, okay, we will supply water at your home. So water supply, then sewer. So once the water is there, then the water consumed will be generated as a wastewater. So another requirement comes like sewericity. Once these two things are done, and then the third opportunity comes here for improvement is a drain city, which is basically drainage. Anyway, naturally might be existing when the city is planned, but at the same time flood production, right? And then waterways, then water cycle city, and then water sensitive city. So these are the stages of a transition framework, I will say. In our country, we are struggling to meet, water supply, sewer and well-drained city kind of thing, because still, during this particular monsoon season, we have observed that a lot of city got flooded. Lack of storm water drainage arrangements. So we are in the initial 1, 2, 3 stages. Mumbai is somewhere better than others because we have a well drainage network. Still, some of the areas got some adverse conditions during monsoon period, but still it's a well drained city. So, but still we are very far. Waterways are not there. We are always talking about Methi River. Can we do that kind of situations and then opportunities explored? Water cycle city, that your limits of natural resources are actually identified and honored, so you are not making any pollution into that. So we are still far to achieve the largest intended goals. And this image generally gives me a little bit a different kind of scenario when we say blue planet, but here the things are very, very different. We still have deficient areas, particularly in Rajasthan and Marathwada also, because I came, if somebody told me that in Marathwada still there is no, or very less rainfall, and that is creating a very big issue there. In Mumbai we have adverse situation, that we have a lot of rainfall. Put together, IPCC is an organization which gives some say indication about how the things are evolving in global world. We can see that climate vulnerability map of India is still making things very hazy, that we have to work a lot. So not only from the existing water scenarios we have to improve and we have to sustain it. And sustainability will come with a lot of say extra efforts. It is not just planning water supply system and delivering it to the consumers. It has a lot of things to go in overall things. Coming to the conventional practices that we have. So if we try to identify the service gaps, we can clearly see that we have say local departments, we have asset owners. Asset owners means municipalities or BHE departments. So they require data, so they receive data, but integrity of data is always questioned. Whether the data is correct, data is updated, data is, I will say, coordinated enough. So where we find, say, gaps, and then that data is supplied to hydraulic modelers, designers, and they generally give, they also interact with the master planner, so the departments. So there is no talk between hydraulic modeler, designer, and architect or master planner. One master plan is developed, that is given to asset owner, and then asset owner will float a tender, and they will assign hydraulic modeler or designer for water supply system, and they will feel that something which could have been improved in the overall master plan is not there. So they will be limited or say to honor whatever is there. So scope and the quality of work will get impacted. And further, once everything is developed by designer, hydraulic modeler, master planner, it goes to project manager. They will implement it without any knowledge what assumptions or opportunities hydraulic modeler or master planner has missed. Still those opportunities could have been say better way understood and say implemented. So those kind of say gaps between the stakeholders are visible. So this situation creates a problem and everybody is unhappy. The department is unhappy and the consumers, they are also not unhappy because they are finding it very unreliable and they remain dissatisfied. So for this situation, GIS can identify certain opportunities. Further, if you see the web, right, problem web, complex challenges. So why water management generally fails? It has a different, you can see there, which are there in the red, say, boxes. Fast-paced urbanizations, so very less control over it. So things are moving very fast, a lot of people are moving in. There is no as such master plan. Master plan, when we prepare a master plan, I still remember there are certain, say, incidences. We tried to develop the master plan for 2012. And when the master plan actually got over from all stakeholders, it was already 2015, right? So your timelines are not matched. There are, say, things which are required. Now coming to technology terms like poor catchment management. So that means that if you have a water source, like for say lake or any water body, there are a lot of encroachment in that say catchment area of that water body. There is no control, and then whatever you are designing, taking that as a source, considering that you will get say water in summer season as well. So during summer season there is no water, means that there was a few catchment areas not performing as per the desired objective. So you have a lack of sources of water. Then you have a poor legal infrastructure to penalize the projects. A lot of projects get delayed and there are say problems. Suppose there is a problem in the water supply network where you needed certain acquisition of lands, so that is not happening, your project gets stuck. And then similarly extreme weather conditions. So we have not accounted, say in most of the situation we are going by certain laws or guidelines. Like for example, if they are saying that CPHU manual says that you have to design water supply system for considering 5 years or 10 years or rainfall event. Now with climate change, you are say very well aware that a lot of incidences are happening of flooding. Why? Because the climate has actually changed. Your say rainfall is happening not on the average annual rainy days which you generally count as per the standards. Your rainfall is occurring in a lesser day, so you have a larger intensities to cater through your storm drainage system. So you are getting say adverse impact. And put together, so I will say a lot of opportunities of improvement are there. It is not only for highlighting the problems, but there are a lot of opportunities. And how those opportunities can be, improved or say implemented, you have to focus for the technical excellence. You have to focus towards the business capabilities. You have to have, say, agility and customization in your solutions. So this slide is not only for, say, individual engineers. This is for the management perspective as well. You have to, say, try what best can be done in the given circumstances and collecting the data. So data is one of the important source for all the three things, and using data, more precise data, more accurate data, you can work towards the technical excellence. Once you can achieve the technical excellence, then you can see the business compatibilities. There are a lot of, say, opportunities where you can increase your performance. You can actually I will share some of the clips in the later slides, and then agility and customization. So what it means that for technical excellence, you can develop certain toolkits with quality data. You can very well identify ways of or mechanism of updating that data. So that regular data updation, validation will give you more precise information, and you can improve your model, your data. Then you have to have, say, appropriate computational analysis, which is, say, a lot of, say, innovations are happening, a lot of tools are available in the market and professional practices. You have to upgrade that. You should not be limited to the old software which are there, DOS-based softwares. You can actually improve much more better than that. You have to see what kind of climate change variability need to be integrated. You have to have, say, multi-criteria decision analysis and value engineering for the cost-effective and sustainable solutions. So contextuality of solutions and local knowledge is very important, just like the previous speaker told about integrating the local in your design and the implementation. So similarly here also we see that opportunity. For business compatibility, that if you have, say, all opportunities of integrating solutions, like one stage, one roof solution, you will be collecting data, using that data and then analyzing it, generating outcome. So that will give you a lot of, say, business sense in terms of data, and then you can focus for the volume-based models and client engagement. Agility and customization means your system once created and should be delivered with minimal alterations. Once you have the data, you can create a mechanism of improving day by day, collecting and sharing it along different stakeholders, different departments. So that will give you say, better opportunity. And easy implementation program. Once your data and your satisfactory level of analysis is performed, you will have that kind of say customization in your solution. Now coming back to the actual say areas where those softwares or those solutions or those methodologies can be implemented. We know about the water, the urban water cycle, I will say, because we are living in urban context. So we have, say, water sources, those creeks, rivers, what we have, and then water bodies. So we collect water and then we transfer that water to water treatment plants. And from those water treatment plants, water is transferred to or distributed to the end users or customers. And then wastewater is generated. So which is generally in urban areas, we are treating it and reusing it for various purposes. Yeah. So in this context, I will say that GIS is an integral part. Now we can see the applications of the GIS. So a lot of say opportunities of using it. We have a lot of software in the market. Say starting with the ArcGIS is still ESRI, and most of the government departments are using ArcGIS. Then we have freely available software QGIS. Google Earth Pro has a limited opportunity, but still it's a data source and can be used for certain kind of presentations. Then we have GRASS, MapInfo, and then we have various other softwares as well, giving different kind of thing. Now, along with that, the GIS software, we have modeling softwares as well. So GIS softwares can do some kind of analysis that I have shared earlier, but after that, all those modeling softwares are integrated with GIS tool because they accept the data what is provided by the GIS input files, and then they also can perform certain analysis and create the pictorial or graphical presentation or the spatial presentation as well. Like for example, if you are doing any analysis with Bentley water jams, you can actually get the pressure at the each nodes, say represented by different colors, water supply network by different diameters. So all those opportunities are actually the GIS tools which are already integrated in those softwares. So we have AutoCAD Civil 3D, HECRA, HMS, MyCurve, then EPS software, freeware softwares are also there. So all those softwares are generally coming now with integrated GIS analytical tools. So what basically the data is required? We require digital elevation model, dam data, which if is not available by any survey, if you are doing any regional analysis, we are generally taking it from the open source. Then climate data from the IMD, land use data, land cover data, which is required for analysis, population and demographic data. So generally we have say published documents, one report which generally comes as a census book. Then we have maps which is there as a census or the worldwide map, and those maps are generally transferred into GIS to create what kind of situation in overall say ward or city is, and those data is analyzed for generating the water say the population densities and the water demand center. So everything is done in GIS, so you can't separate it out. Now it is very important you get the right data and then use the right kind of tool and generate the outcome. So these are some examples for water management that we have utilized GIS. You can see the first is the groundwater assessment. So when you use terminology groundwater assessment as a water source, you need to know what kind of opportunities of abstraction of groundwater is on a sustainable basis. You can dig any area through the machines, but whether the water will be available or not available will be a question, and what kind of quantity and quality. So hydrogeological investigations are required by doing certain investigation at a certain say interval. You use that data, feed it into GIS system, and then you will get the overall say interpolated maps, and then you will get the say presentation which is there in the first upper left corner. So you can actually identify the locations where you have to dig your borewell. So those kind of assessments are very important when you are say planning any water source for any kind of development. Then water demand assessment. So what is your area you are going to feed? So if you have say many say ward and with different kind of densities, like somewhere you will have say high rise buildings, somewhere you will have say low rise buildings, somewhere you will have slums. So what kind of demand actually you have? So you have to map that demand and then come out, okay, now these are my demand center on a particular map, and with those demand center I am targeting my water supply system to be efficient, that whatever quantity I am planning to give is actually reaching there with desired kind of pressure. So those kind of opportunity will come once you have the right kind of map for the demand centers, and once your demand centers are identified, then you will use that data in your software and actually design your network system. And further, for network system once designed, you can have a different kind of interpretation methods to identify where my pipes are. If you are dealing an existing situation, brownfield kind of project where existing water supply network is there and you want to improve it, then your existing water supply network will get examined or evaluated based on this system, and you will see that whether my pressure is sufficient, supply is sufficient. You can have a different kind of color combination which is there in the say lower right corner. So those opportunities of presentations, analysis and decision making is very quickly generated through GIS softwares and GIS tools. Similarly, for stormwater management, in stormwater management, to actually start with the catchment area delineation. Your catchment area delineation is very, very difficult if you are using manual tools. Nowadays, a lot of softwares are available like QGIS, RGIS. You feed the dam data and you will get the say catchment area. You can very well say validate it through site visit. But yes, if the regions are not accessible, like you have a very large region like Maharashtra where a lot of say hills are there, these tools are very, very important and essentials and useful. So once you delineate your catchment area, then the runoff coefficient generally is required to be calculated, which your LULC maps will help you in getting that value. Once those parameters are there, then you have say different softwares to generate formulas to generate your runoff. So those runoff values are very critical for designing your stormwater drainage network system, and also taking certain decisions whether you want to have say some kind of comfort over different rainfall return period event. You can make your city practically as a climate resilient city if you follow the proper data sets, proper approach, and proper design softwares. And then those parameters can also be utilized for your internal stormwater drainage, roadside drainage system, and for any city inside areas. And similarly, when you are planning for rainwater harvesting, so you can see in the left hand side, these are the images from Rajasthan. You can see these kind of kui system and pond system, and they were existing right from the say civilization or say royal times. They have that kind of wisdom there. But now, with the evolving time and with the evolving situations, we have a lot of tools available, we have a lot of knowledge available. We can utilize those knowledges and actually identify right kind of areas where rainwater harvesting structures can be planned. Those structures can be say pakka concrete structures or maybe natural structures, depending upon the situations, and we can actually increase the rainwater harvesting potential to meet our say different goals. Similarly, for the wastewater management, we have different approaches which anyway use GIS. You have to identify the different waste generation centers, and for those waste generation center, you can identify a right kind of place for STP. You can have say centralized STPs as well as decentralized STPs. You can evaluate the reuse potentials and then take a decision whether you want to have say STP at a remote location, or you want to have STP at a place where you can actually utilize treated wastewater. So those opportunities generally come when you use the GIS softwares. Yeah, so I will not take further it. So thank you everyone for listening, and thank you sir again.
Thank you, Dr. Solanki. It was very exhaustive and informative lecture on this GIS. Actually, I was got a little bit nostalgic. Actually, my first seminar, 4-credit seminar was on digital terrain modeling in 1983. But now I've forgotten most of it. We have got very good information, and in Mumbai also we actually got water utility maps in AutoCAD format only, and we recently converted into GIS. Of course, conversion was done with the help of existing maps, AutoCAD maps, but validating that data in field was really difficult. The existing data validation is very difficult, because either you have to take the actual pits for the exact GPS locations, or you have to have some old maps exactly having the geo coordinates and all. And another way of doing it, I mean, if you can have the hydraulic model of it, and so that you can ensure that none of the watermains are missing from the network. So anyway, we tried it, and I think out of 23 wards, 24 wards, we did 15 or 16 wards. You have completed, and the rest of it is yet to complete. Any questions from the audience, please?
So India, I will say a lot of natural opportunities we have. We have a lot of lakes, and the only thing that you can identify along the coastal regions where rivers are actually merging into the sea, other land parcels where we have water bodies, we have not I will say human man-made structure, natural man-made structures, you will find lot of things are happening naturally, but over a period of time it is deteriorating. So on the one hand we want to increase it, other hand we are destroying it, because catchment areas are not as productive for them as intended. So things are critical. Still, there are certain figures which seems okay for us, but it's not there.
In the country where now there are efforts being made for CMS, the continuous mode systems, there is a requirement that the non-revenue water is brought down substantially. As the earlier speaker told us, they have achieved somewhere between 10 to 15%. Now, for this, and he also explained that there is main location of loss is on the consumer connections. So, do you know any cities where there is geotagging of all consumer connections that has been done already?
So geotagging means in the terms of metering or in terms of locations?
Locations means in the form of meters as well as consumer connection.
I think, sir, Dilip ji will be the right person. But yes, we are aiming for, we are doing 24/7 water supply system for the Leh city. We are aiming for geotagging that. Every location will be on GIS, and every house owner will have meter, and that meter will be connected to online system. So we are planning. Leh city, Ladakh.
Mr. Pandit, I have this one answer for this, because we tried in Mumbai for geotagging of the meters, and problem is with it all high-rise buildings and location of meters, that we are not able to get the GPS coordinates for that particular meters, and sometimes because of this satellite shadow effect or whatever it is, you are not able to get the GPS coordinates for that meter locations also. Yeah, so accuracy is the issue in that case.
So for a spatial area, that is densely area, it is difficult.
It's very difficult. If there are no questions, we can conclude the session.
Thank you. Thank you, everyone.
So it's knowledge earning session. I would like to request Shevale sir to come on the dais. We are felicitating Dr. Anuj Kumar Gorpade sir. Thank you. We are felicitating Dr. Shailendra Singh Solanki. Light. Sri Argade sir. and Organizing Secretary Sonawade sir. So now is the time for lunch. It is on the second floor near room number 103. Terrace hall. Pardon? 2:15 we will assemble here.
Excuse sir.
Good afternoon. I know it is difficult to attend second session after the lunch. Difficult for me also to conduct, but nevertheless, we will start now. This last session is on past experience, PPP model, and delegate of experience. And I am inviting Engineer Sunil Vaidya and Dr. Rajendra Ganatra on the dais for their presentation. I myself is the moderator of this presentation session, and I will introduce now Mr. Sunil Vaidya. Sunil Vaidya has a rich experience on water and wastewater sector. He has worked with one of the leading Asian municipal corporation of India, that is Bombay Municipal Corporation, for 34 years, and out of that 27 years he has spent in water and wastewater sector, and in particular of that 4 years on the continuous mode water supply or 24/7 experiment of Bombay Municipal Corporation in K East Ward. He is associated with our Indian Water Work Association also since long, and very active member of Mumbai Center. Now I request Mr. Sunil Vaidya to make his presentation.
Thank you. Subject is experience of Mumbai Municipal Corporation on CMS. Actually, it will be my experience. To start with, I am Sunil Vaidya, retired BMC engineer. I did my ME in civil environmental from VZTI. I am having 2 years experience in MADA and 36 years in BMC, and out of which 27 years associated with water and wastewater sector, that is which was my subject at academics. And fortunately, on pilot project of continuous mode of supply, I was associated in one of the 2 wards, that is HVS ward. So while I was in western suburb, south area, that is H and K wards, H East, H West, K East, K West, I was distributing 550 MLD to 4 wards. And that time in 2015 or 16, H West ward was selected for pilot project for 24/7. And I was got associated for the works. In all, 5 chief departments were involved in the works on the site. WDIP, Water Distribution Improvement Program, was a department set up newly somewhere in 2008, exclusively for this purpose. And then they have designed everything, planned everything, and the project was started subsequently. That department was chief department. Fortunately, Argade sir is there, who was who was head of that. And on the site in the wards, distribution section, that is ward, leak detection section, service provider company, construction section, and maintenance sections were chiefly working all the 4 years. This work was also, second pilot project ward was T ward in Mulund, that was in eastern suburb. Suez was service provider agency and consultants for the work. It was not PPP. These various sections of hydraulic engineers were executed all these works, except few works from outer agencies. There are in all 10 components or services in this pilot project. These are enlisted here on the slide. network survey and GIS mapping, network modeling, zonal equitable distribution of water, and assistance toward achieving 24/7. This was main. Leak detection, customer survey and database, customer relationship management, asset management, water solution for slums, quality assurance, and training and knowledge. Out of which 5 number, 6 number, and 9 number were subsequently dropped. Customer survey database, customer relationship management, and and one more 9 number were dropped. The rest were carried out of which in some services I was associated. So to start with, what was HVS ward at that time? It is population at that time was 12.43 millions of Mumbai and western suburb 5.5 and HVS was 0.37. Water supply total to Mumbai was 3,800 MLD. To western suburb it was 1,500 and to H West it was something 115, 120. Distribution network of Mumbai 6,000 kilometers, western suburb 3,000 and H West was 200. What was supply hours, supply zones in HVS ward? So there were in all 10 supply zones. The 10th one was pump supply zone and the remainings were having timings which are shown in 2 columns, before project and after project. So in the last column you can see the increased duration. It is something half hour to 8 hours in different zones. I will come back to this slide again after last of the lecture. This was the services, the first service, a network survey and GIS mapping. So network survey and GIS mapping was done by appointing an agency, by taking PIDs and by help of line locators. And this was taken on the GIS. And whenever we need these water mains on the site now, we can refer to the GIS and we can go to the site and pinpointly can mark. For which, after the submission of the sheets, GIS survey sheets, leak detection department and ward have done 5% check of the sheets. So we both departments randomly selected 5% sheets, and those sheets were marked, were kept on the table and marked randomly at some points, and on the site from GIS we have marked on the roads, and we dug 1 meter by 1 meter trenches and we found water mains there in that trench. So GIS survey was okay, and which was accepted, and we are using now. There were 385 sheets in total in HVS ward, out of which 27 we have checked. In each sheet, 27 sheets, approximately 3 places we dug the trench on the site. The deviation was within that trench, that is 1 meter by 1 meter. Mostly it was found at central or either to the left or right side, but in that trench, that is half meter deviation, within half meter. Then these are some pictures we have noted. These pictures are, these photos are not from HVS ward. Simultaneously S ward was being done, and these, unfortunately I didn't got HVS photos now. So these are SWOT photos. But you can see the same thing here. We have got water main in well within that 1 meter by 1 meter trench. Then leak detection was one of the component, and regarding leak detection section of the MCGM BMC, there is a one chowki in each ward. That means 24 chowkis are in 24 wards, and they are having at least 2 sounding mukadams and their teams who are doing soundings to detect leaks and hidden leaks, and other staff are surveying the ward for visible leakages. So leak detection quantum of HS ward, you can see in 2000, this is the Greater Mumbai figures. They are ranging 39,000, 33,000, 35,000, 36,000 leaks were detected by these 24 ward chowkis leak detection sections. And in case of HVS ward, you can observe in 2015-16, leakages were over 1,000, 1,300, and after this leak detection drive, there is sudden drop during those years, and again little rise you can see. So when this pilot project was started in HVS ward, we took a special drive because it was a component. So we have to eliminate leakages because we will be going on the continuous water supply, and leakages would have been more. So this drive was taken under the pilot project, and it has 3 components, 3 categories of leakages. Those are type 1 leakage. Type 1 leakages are visible leakages, and a massive survey was done on the ward during supply hours to note down the visible leakages and were attended. The type 2 was by opening covers, like covers of sluice floors chambers, drainage chambers, stormwater dhapas, and any MTNL utilities chambers. So many times leakages comes in that chambers, and we can find some leakages nearby somewhere, and were attended. The third type was hidden underground leakages detection. It was done by helium gas leak detection method. And you can see the results of that special drive during that period, say of 1 year. We got type 1 188 leakages in type 1, 48 in type 2, and 237 by helium gas leak detection method. So helium gas leak detection method, we have intruded helium gas in the pipeline 76 occasions in a period of say about 10 months, 76 days, 76 days, and some 50 times intrusion of helium gas. And we have covered 200 kilometer of the water main in that, which would have been taken a long period if we got done it from sounding mukadams. And as per the jurisdictions of our HE department's works, the leakages of small diameter, that is GI pipelines, service connections, were get repaired through ward maintenance, ward chowki. The diameter of 80 mm and 300 mm is the purview of construction department in our HE's department. So they have attended leakages of that diameter pipes, and above 300 it was done by maintenance department. Helium gas leak detection method, I have some photographs. This is drilling and sniffing operation, and this is spectrometer where leakage can be noticed. So coming back to that slide I told you, this one. Now this slide shows the district meter zones timings prior to the pilot project and after the pilot project. In between, after network modeling, that is our second service, and PRV installations were done, HVS ward was kept on CMS, not exactly 24 hours, but we were increasing the time, and water quantity was requirement was more. When water supply requirement was increased gradually for HVS ward to be on continuous mode supply, but it was felt that water addition need was much more and not copable. Then the ward was kept on increased supply hours, and which are shown in the second after WDIP supply timings. So in all, we got increased duration during this pilot project, and those are there. And we are not getting now short supply complaints. So that time we were getting a lot of short supply complaints from particularly 2 supply zones. So to concluding, my observations are, after this pilot project, initially we were on the 120 MLD to HVS ward, is now we are on 150 MLD. It is also due to population increase and increase in timing. Short supply complaints were stopped, almost no. By deleting and arresting 473 leakages, water was saved, which is shown in this by Darcy-Weisbach method formula, and bucket measuring was done every time. So that is also can be seen here in the table. This much water we saved at that time, but if we saw in the other table that again these leakages were on the rising. It was come to the 700, 800. Water solution to Gazzarbhan slum was done. Actually we have solved that problem that time, and slum area without pump trials were taken, and slum areas were getting water. Training and knowledge quality assurance reporting system, these are the services in that, and those were complied with. Training programs were there, knowledge dissemination, even to the sounding mukaddams. Additional of water could have been diverted. One more thing I can put, that additional of water which we have added in the pilot project could have been diverted part of the ward, and part of the ward could have been on the CMS. This is what I think, which might have a milestone analysis for in next few years. Negative mindset was, I have observed my staff and colleagues were not sure that this will be successful, and a lot of efforts I took that time to convince them that we should succeed, that we should take ahead the program. I can say in Chandrayaan India was 2 was failed, but they continued, and at 3 they succeeded. And one more thing I want to put in this our seminar, that in Mumbai, where our average annual rainfall is 2,500 mm, which is by seawater evaporation and desalination by nature, and give back to us, then why desalination of plant we are installing now in Mumbai? This is one question I just taking opportunity to ask you. And are we engineers are not unable to store the 2,500? Can Mumbai keep huge ponds in place of development in buildings in each locality? These are the 2 things I may say in the, we can put a next seminar also. Thank you.
Any question? Question experts, Mr. Milind Pandit.
Non-metallic water mains we have not observed. All are cast iron or ductile iron water mains. And NRW assessment was done.
Those were the major components in the NRW. But physical loss component in the NRW as per se was lesser than.
So I wanted to check on how much percentage of NRW was non-physical and how much was physical.
Physical was I think around
percentage of total NRW. How much was physical and how much was non-physical?
They had given us in the pie chart actually, but I asked him what the actual specific locations and all digital data, but they didn't give us the digital data till I was there. I don't know how that. But these were the components in that, and in that the physical losses were shown very less. So that is why I was interested in actually metering errors and meaning where I am losing my revenue.
There were no test reports given by them?
No. At least whenever I was there, we know what was. And Mr. Vaidya, you not name your colleagues for discussion because 3.74 lakh population with 120 MLD, it is 320 LPCD. They are consuming in intermittent system. So when you converted part of it into not even 24/7, you only extended supply hours, that supply was gone to 150 MLD. It was actually 170.
Yeah, I took figure 150 just in last week.
Yeah, so it was more than 150 also, but the might have some supply, so much was must be adjusted. But 150 LPCD, 150 MLD also converts into 400 LPCD. So with 400 LPCD, you are getting supply. I don't know what will happen when you convert entire this thing into
True.
Mr. Vaidya, express his view on K-Ward experiment. Yeah.
Digital water meters like electromagnetic water meters or based on electronic sensors and all that. So whether you explored use of digital water meters, and then that will my understanding is that will give you better assessment about the water consumption and where things are taking place. So where you see now as far as the use of electromagnetic water meters is concerned.
In this pilot board, we have installed automatic AMR meters at the beginning of the project, and that was assured that all properties, almost all properties, were metering at that time.
Because what we found that all the intermittent systems, mechanical meters are losing air and all sort of damages are there. So we have studied all type of meters, and now we have come to the conclusion that PVC, I think still I guess.
Still we have the conventional mechanical.
Yeah, the conventional, yes.
Any specific challenge you had, any specific challenge during your innings as an engineer in BMC? Did you have any particular challenge, especially with regard to unauthorized connections? Because all that ultimately affected the water. It was a kind of water loss. Anything of that sort, that's what really brief.
Yeah, further adding to that, sir, is there a big study or legal issues happening? Root cause analysis.
That was a real challenge at that time when you started with all this. Now we are
Unauthorized leakages are always there, and whenever we found that, ours is the system when our meter inspectors are moved for the meter readings, and one of the duty is to be keep watch on the all these things, and whenever they found so, or some complaint sometimes comes, we took action. In some wards, in slums particularly, there are many complaints, and we keep on taking actions. And root cause of leakages. During that pilot project survey, we were focused on to find out the leakages as many as possible, and not so root cause or something. But leak detection department, as a leak detection department, I can say you that it's a continuous process, and leakages every day, new leakage form. And that's why we have strong leak detection department in all the 24 wards. And you saw the figures, how many, about 30,000 or more leakages per year we found in Greater Mumbai area. So we are vigilant, and we are attending the leakages continuously. When a leakage happens, many times on one water main, we replace the water main, and every year there is a water main replacement programs. So old will get abolished and new will start.
I think the debate will continue, and we'll move on to the next speaker.
Because now they're completing course curve to curve. All the utility models are under the road.
Sir, we will continue that discussion in the panel because we are going to track. Okay. So I will now invite the author to introduce himself. We are fortunate to have him here, Dr. Rajendra Ganantra. He has 3.5 decade experience in recovery and restructuring, project finance, asset reconstruction, corporate insolvency resolution, including as MD and CEO of India SME Asset Reconstruction Company, promoted by SIDBI and banks. After initial 5 years as engineers, he became visiting faculty for project finance in Indian Institute of Management, Trichy, Visakhapatnam and Nagpur for project finance, then merger, acquisition and corporate banking. He is visiting faculty in the School of Management of Narsi Munji Institute of Management Study, Mumbai, for infrastructure finance, project finance, law of bankruptcy and insolvency. Training faculty for projects and infrastructure finance with Indian Institute of Banking and Finance. He has 8-year experience in corporate sector in top management position, namely Hisar Steel as a CFO of Brahmanami Rivers Pellet Limited, Group Director of Avijit Group, Group Executive Director of SKIL Infrastructure Company and so on.
I think you can shorten it now.
Yeah, it is finished. You can add few more in your further course of life, and we all are eager to hear something of finance side of the all infrastructure projects.
Here after my mechanical engineering from, thank you very much for your kind introduction, and pleasure to be with the water experts here. I did my mechanical engineering, BE in mechanical engineering from VRC Nagpur, that was Regional Engineering College, now it's called National Institute of Technology. My first job was with Hindustan Aeronautics Limited, and I drifted to finance after 5 years, and That's what I continued all the while, including as MD and CEO of an ARC also. It was all finance function. But I had opportunity to do a lot of PPP projects, including a very famous Tirupur Area Water Development Corporation. I had done that, and I had done the debt syndication of it, and we had a lot of apprehensions, and we learned some lessons from that failure. Having been, having been born in Nagpur, I have also tracked the Orange City water, which is being shown as a big success, but I have my own views. So I'm going to talk about, what are the determinants of success for financing of PPP projects, and drawing from the failure, what should be the way forward? So allow me to go ahead. When we talk of public-private partnership, essentially we are talking of, the two parties coming together, the government and the private. Now here, allow me to digress. If you compare the performance of, let's say, State Bank of India and HDFC Bank, there's a big divergence. But the fact remains that it is State Bank of India which has, created so much of quality, manpower, bankers who have manned so many banks and done wonders there. Somehow, SBI, relative to HDFC, languishes. So what I'm trying to say is that the government entities, barring some very honorable exceptions like ISRO, have a problem of adverse selection and moral hazard. Somehow they tend to do that. But in the private, the business processes and the HR processes are such that people are incentivized, and ultimately they do get rewarded also. If you look at the HDFC Bank, the ESOPs are phenomenal. I don't say that yet there would be no problems. There are problems which happens, but much less. In government, it happens more. And that's why, we're talking of PPP, where we are talking of blending the strengths of both private sector and the government. And the whole idea is that the private sector is allocated and to mitigate the risks which are financing, design and construction and operations. The government authority is expected to mitigate certain risks, which are in their domain, like land availability or, right to use or way kind of risks. And certain risks have to be shared and mitigated. For example, if it's environmental, you would have seen that even BOT projects, some of the best promoters moved out long back, of course, about more than 10 years ago, from the road projects development because they were not getting the environmental clearance. And you all know that the whole process is straightforward. You have a rapid AIA, the environment management plan, you go and make a presentation, you get a detailed TOR, you finish that and make further presentation, and you get your, in principle, approval if you have done a proper job. So why should it drag on? But nevertheless, there are some practical issues, and here the government can come and say, declare, that we are there to mitigate those risks. So this is the whole idea about it. And when we're talking of the rationale of, there are always debates. Some people say that, government, this is a public good and only government can do it, etc. So there are certain, objectives from government side of point of view. There are certain challenges. And if we quickly look at it, I have deliberately made it very telegraphic so that we need not get into too much of a, discussion which is descriptive. Allocating financing, construction, operating risk to private sector, right? So challenges, ensuring reasonable tariff for the public goods to serve public interest. This is very doable. And if you have seen, the ultra mega power project showed, and before that in late 90s, the tariff-based competitive bidding of the Andhra government had shown that yes, PPP can really lead to blending of efficiency with a value to the consumer. And if this is possible, the government's objective should be achieving value for money by ensuring that the cost of the PPP project, lifetime cost, which would mean that the capital cost, which is, let's say, amortized per unit of whether it's power or, let's say, kiloliter of water, and operating cost, the present value is the lowest or lower than what the government would be able to do. Point is that a PPP is justifiable if there is an X amount of saving, of which a part is being retained by the private sector, which gives him the return on equity, and the rest is being passed on to the public. So that is very important. And this may sometimes mean viability gap funding. So that can be minimized, and that can be minimized only through competition. If you know the Metro 1 project, there was a viability gap funding demanded of 1200 crore. Somehow it was brought down to 600 crore, and today it's suffering. So this, with the advantage of hindsight, you know that even that was, a very fair competition which resulted in a fair figure. Ensuring reasonable tariff to the consumer, the way is competitive bidding, of course, and timely completion. So you have the right RFQ process. So these can be met by adopting transparent processes. And we have demonstrated in our country that it is possible to do it. Private promoter, he wants to have certain risks mitigated by the government and project viability. And the moment the government declares that, okay, this is my RFQ, I want to pick up the best people, and this is my RFP, in my RFP itself I am making a declaration that, look, these are the risks in my domain and I am going to mitigate it, I am responsible. I can challenge that the kind of competition that you would be witnessing would be enormous, and ultimately, the best price discovery happens only in the market. When you look at, again, the rational part, the project affected person, compensation for land acquisition, who will give that? That's obviously government's domain. It entails cost and legal risk, and this has to be done by the government. And when it comes to consumer minimum reasonable tariff, and if PPP is structured based on value for money, then it's going to be possible. And that's where later on I'm going to, in fact, I'm saying that government has to have its policy for giving a project. It should not suddenly, make a declaration from the rooftop that we have decided to give something for on PPP basis. On what, on PPP, with adopting PPP structure, on what basis? There has to be a basis, there has to be a policy formulation. Now, some issues about the debate which goes on. Water is an economic good, for privatization, and therefore there should be smaller government role. The private sector advocates would say against privatization. They'll say that it's a public good, and therefore government should manage it. The fact of life is that it is both economic as well as a public good, and excess of private sector can be eradicated by regulation through concession agreement. I think India has matured in a regulation, and through a concession agreement it can do it. Why the BOT projects in toll roads failed? Because they got commoditized. That's a different subject. I have handled it, so I know it. That's a different subject, and what the promoter started doing was they would give a contract to the, the group company who would derive equity and much more. So there were some issues there. But otherwise, we have demonstrated that we can do it. So here again, it's an emphasis that this PPP structure can be adopted with a value for money. Right? Then efficiency. Private sector is efficient, and therefore it must be doing this. That's what is the argument. Public sector is efficient is the argument of other people. Facts are known. Arguments for privatization can be realized by transparent bidding. Again, the mantra is transparent bidding, and ultimately, if you feel that the private sector is going to, fleece the customer, it has to be captured in the concession agreement, and the increases can be driven by a formula like they have happened in case of the toll roads. Toll roads are now out, and now we have the hybrid annuity mechanism, but they are out not because of this kind of failure. It's a different kind of a failure where the risk was transferred to the banks by padding of some private sector. This was broadly my point on PPP. And PPP is successful if you really ensure value for money. That was the crux of the matter. Now let's say the past experience, and this is my direct experience. This was formulated in 1998 I was the general manager of Industrial Development Bank of India. Now it's IDBI Bank in Mumbai. I had done it. It was for 155 million liters per day. It was to draw the water from Kaveri river, storage, distribution of 155 million liters per day of the water to Tirupur municipality, Tirupur industry, and the wayside villages, and wastewater management also. So it embedded even the rural component. And there was a beautiful cross-subsidization, one could say. The municipality was capturing about 60% of water, but it was contributing 5% of revenue. Yet it was turning out to be viable. The cost of the project was 1163 crore. But the interesting point I have mentioned here is that 2 years later, the same project with the same configuration and capacity came down to 1050 crore because the World Bank insisted on international competitive bidding. An example where genuine competitive bidding can discover the best, economics. We have experienced in our cases also. This was the kind of funding, a very substantial equity, and 698 crore was the debt. And total was 1163. This came down subsequently, as I mentioned. And can you believe this project was supposed to deliver a 20% IRR over a 30-year period. Now, this is a kind of, you could say, a loot. 20% IRR over 30-year period, and that too with this much of debt. So it had, one could say, far more, scope for debt, if this were true. But we became very apprehensive because ILNFS, which had, was a proponent of this, was keeping only 9% equity. Now, tell me one thing. If you have a company where you are going to earn 20% IRR over 30-year period, right? And the kind of domain that you will develop will keep you going on and on for perpetuity. Will you keep only 9% and give everyone at par? So this gave us apprehension that probably it didn't believe its own words. But nevertheless, this was a classic case which could be done. And the documentation was very good. So we went ahead. Let me go further. So when you talk about documentation, there were 2 EPC contracts finalized by 2 reputed contractors, Mahindra & Mahindra and Bechtel and United Utilities of the UK. We have Mr. Dilip Sonavane, who was in those days with Mahindra & Mahindra, and he is also aware of it. O&M contract was finalized with the joint venture of United Utilities of the UK and JV with local partner. So the project and construction and operational leaks seem to be mitigated. I am saying form over substance. Everyone looked good, right? 30-year concession agreement was signed with Tamil Nadu government. The concession agreement allowed a project IRR of 20%, which I have already mentioned. And extension of the concession was permitted up to 50 years in case the IRR would fall short of 20%, right? And the project failed mainly due to mismanagement by the project company, failure of the Tamil Nadu government to implement its part, and dispute between Tamil Nadu and Karnataka over the sharing of the Kaveri water. I will highlight the first part, project management company. Now, if this kind of a company is to be run, if I were to be assigned this job of getting somebody like, I just heard Mr. Sunil Vaidya, I would say, why don't you come and handle this matter? Or someone like you or your team can come and handle. But here a bureaucrat was given this job. With due respect, bureaucrats have their own strength. But here you need sheer domain expertise because the expanse is so much of distribution. This was the biggest undoing. And besides, of course, ILNF has its own problems, which you can always Google and get from the chat GPT. So this was a tragedy which we faced. The failure of Tamil Nadu government and even the lenders, I will highlight going further. Government failure, it was half-hearted approach. Did not ban the groundwater abstraction in Tirupur, which was supposed to be there. See, the industry was abstracting the groundwater, and there were, those water distribution lobbies, those tanker lobbies. Now, if this is your job to ban that water abstraction, let those fellows find another way out. They are business folk, they'll find out. You fail because you get buckled under politics. This was one. Probably the lenders would have said this should be a pre-commitment condition. First you do it and then only a farthing will move from us. But a good faith did the banks in. That was a fact of life. did not reach agreement with the government of Karnataka beforehand, we had raised this problem. They said that it's going to be only 1% of the Kaveri water. In the worst of the drought, it would be 9%. But 1% can also create a big problem. It serves a big area. And allowed the project to be developed by ILNFS, which had no credentials. And if you really look at it, it is a domain expertise and the credentials which make a success or failure. This was total lack of it. Lender's failure allowed a weak management. We did something on it, but that was not enough. I can say with my hindsight also and with my experience. Assume that the Tamil Nadu government would do its part without fail. This assumption will not do. The people are very busy, they have too many things to do, they get transferred. So unless you put your foot down, you means I would say for the bank, it doesn't happen. Did not act on the apprehension they had evident from the promoter's stake of measly 9% of the equity and total lack of monitoring. I may make a bad investment decision, but if I don't monitor it, I'm allowing myself to be looted. So that was a problem. If my project implementation schedule is, captured in the project phasing in my documents with quarterly milestones and quarterly drawal of debt and equity and progress, and monitor against that. And if I see the first major variance, I stop it and I said, fix it, and then only we'll move further. That was a big problem. Tamil Nadu government, by complete mitigation of project political risk, it could have done by selecting best partner through RFQ and RFP, not a doctored RFQ and RFP. I can always, do a perfunctory job, which has been done a lot in many sectors, but UMPP was an exception. UMPP had only one negative point, that it created winner's curse. They became too aggressive. That was a problem, otherwise it was a thunderous success. The project was granted to ILNFS based on nomination basis without any VFM or social cost benefit analysis. This was a failure. So I'm talking of, consider these points. IRR criteria was too lavish to be of the benefit to consumer. 30-year project IRR was almost a loot. Extension by another 20 years was too lavish to recoup IRR shortfall again. There was no regulatory control on the finance operations, hence cash flow could be potentially manipulated to depress IRR and claim extension. There is no point in expecting some very ideal behavior. Assume that if the things can go wrong, those will, Parkinson's law, and provide for correction timely basis. That was not the thing. And by rigorous monitoring, they could have avoided. But that was, nothing was done. Government was totally unconcerned. What skills did the TN government need it? And these are all relevant for us. Undertaking the project feasibility. Now, I have seen many times that this is because L1 criterion, you end up, saving some small money for a big potential cost. We have any number of examples. For example, in late 90s, Australia-Japan Cable had set up a subsea cable project from Australia to Guam Island in the Pacific Ocean, that was US territory, and Japan, through via Japan, Guam, Japan. That's how they would cover Japan and the American continent. They had spent $6 million for feasibility study on a project costing $520 million. So obviously, of course, here the terminology uses DPR. My point is that, when we are doing such critical projects, and critical for water is an extraordinarily critical thing, we don't need to mull over it. There should be not one feasibility study. In fact, there should be two feasibility studies by two different agencies. Let them charge whatever they can through a bidding route, definitely. Often when you have competitive bidding, you have a bid evaluation, you have criteria. Pick up the best, who can give the best results, obviously. And proactively when we do it, I can tell you my experience in case of Videocon Power, Mott MacDonald had done an amazing job as lender's engineer, but it was a power sector, it's just an example. And in case of Daewoo Power, the same Mott MacDonald had to be relieved of the responsibility. Why? Because, you know, in Daewoo, probably they created a team of, you know, all novices who didn't know very much the thing. So they were learning at the cost of the others. So my point is that if you are proactive and if you are picking up the, you know, best agency, we can come up with the really best feasibility, and then the project sizing configuration to the last detail is available, and on that basis when you are bidding, I think you are solving half the problem. See, if we don't plan, we fail. So, you know, if you're planning, then you are avoiding failure kind of thing. I'm not saying that you means I'm making in a general term. I'm not addressing you. Everyone it applies to. Understanding how the EPC of the project could be optimized and structured. You know, if you are in government, you have an engineering department. I'm addressing right now Tamil Nadu, any government. Great engineers are there. If they are given responsibility with a focused outcome, I'm sure the results will be awesome. Understanding project risk, taking project risk seriously and mitigating the same by finalizing arrangements with Government of Karnataka, that's what they should have done. Banning and enforcing groundwater abstraction. Stipulating in concession agreement deterrent action for the case in case of delay in project construction operations by the project company, and project monitoring. Often people put, you know, project monitoring, but they don't monitor it. Conclusions, understanding all facets of infrastructure development that is needed, market demand, project formulation, technical, commercial, legal, financial skills, project viability and valuation skills. See, the moment government knows this is my value, right, it's no big deal. It's a matter of training and some example of your own projects. Once you have a, you know, idea of the value, then bidding becomes easy, of course. Project finance skills, so that you're very clear about, you know, what will lead to great financing for it. That will ensure that more and more people, private fellows, could be attracted for bidding. And obviously project monitoring and speedy corrective action. Orange City Water, I just mentioned that it's my birthplace, so I've been very keen observer. Unfortunately, I don't have too much, but whatever I have is disturbing. 24/7 water supply project for Nagpur city under PPP was awarded in June 2011 to Orange City Water Private Limited, a 50-50 joint venture between Veolia. Veolia of France has a great background, definitely, and Vishwaraj Environment Private Limited. And you know, since this was for Nagpur, I in fact acquired a debt sanction memorandum of a bank. The cost was 575 crore of that project. And it was for 25-year PPP contract, 25-year concession with Nagpur Municipal Corporation and Nagpur Environment Services Limited, with exclusive right to operate, maintain, refurbish water supply infrastructure owned by NMC to deliver water supply in Nagpur city and to collect corresponding water charges, right? This was to treat water that it would receive from NMC for purification. No big deal here. It's chlorination and reduction of the, you know, TDS. And no big technology involved. The open source technologies, open source engineering involved, would collect the amounts billed to the consumers as per the rates prescribed by the NMC. This was very strange. If you are saying that the project will be bid out and the people who quote the minimum tariff will be the winners, how can they figure out the tariff to be charged when the price is to be determined by NMC? Now, NMC may have its bylaws, but when you are doing PPP, make sure that you don't have legal conflicts. But this is one problem which you can see. There could be other problems also, and yet people did bid, you know, their minimum tariff they will charge per cubic meter, and one of them won, of course. I don't know, there were about, I think there were about 5 bidders. Ultimately, one fellow won. I think in the later stage, in the final stage, a couple of them were there. But in any case, the project was to be completed by 5 years. My source of information is the bank note and the press, of course. NMC was to receive grant under JNNURM for rehabilitation and expansion of water supply system. And often when you are talking of PPP, you are talking of a situation where the government doesn't have money, right? The authorities are short of money. Here substantial money was available. Suddenly there was a news that it would be given on PPP, but there was no criterion which was followed, right? If I have to give, I have to make sure that this project under PPP is going to serve better the consumers than under government. And for that, value for money is there. And value for money is lifetime, cost. If lifetime cost is less, the tariff would also be less. And we have in power sector, when these are given, there is a levelized tariff. It's simply, if my levelized tariff, per unit is, let's say, 3 rupees 20 paisa, and if under government it's going to be 3 rupees 50 paisa, there is a value for money to the extent of 30 paisa per unit. Project gets justified, and it's doable here as well, right? The project has not been completed. The local promoter was allowed to exit from the project, and that is something which is astounding. And NFC has issued termination notice to the project company, which consists only of Veolia of France. What happened here? The authorities did not ascertain the value for money before resulting from the project. The rationale for PPP, therefore, was not established. So you are giving out of the blue making decision. The large consumer complaints today show that the project is unable to deliver a great quality despite high tariff. Can you imagine? You have to only bring down the TDS level to something like 500 and cleans water, of course. There should be no biological demand kind of thing. Hence, the PPP structure has failed to deliver, notwithstanding whatever the website would say. Now, what are the determinants of successful? And I have seen even Italy water projects and some other water projects, including the wastewater projects, industrial wastewater. I had handled World Bank line of credit for pollution control and prevention. I had handled the CETPs, common effluent treatment plants. They have been by and large successful, except that there are problems about the industry supplying, not maintaining sometimes pre-treatment standards. Otherwise, they have been doing well. So I'm not covering that. Requisite qualification of the qualified biggers. In both cases, there were issues. I will only stop at that. ILNFS simply didn't have any credential. It was nominated, right? The other one also, if you could see in detail, you will figure that out. Robust feasibility study as a basis for project formulation. In case of Tirupur, I don't think the government had done anything. In this case, I have my serious doubts. I will stop at that. Clear project site configuration and deliverables. There were issues about this as well. Unambiguous sharing of the project risk by two parties and mitigation. This was obviously not done properly. Both the parties failed. And lack of project monitoring. As I mentioned, I may make a bad decision, but if I am monitoring how it's moving, I can stop it. In finance, we talk of stop loss. If I am investing, right? I may do stop loss if I am in a short term. Of course, a person like me doesn't get into short term. I am a fundamentalist, so that doesn't happen. Otherwise, there are stop loss concepts which can be applied here as well. I did 3 project financing of Reliance Industries Limited. Beautiful project formulation, but they did not implement. They abandoned it because there was, after all, project development is a sunk cost, and 2 of the costs there were better alternatives. So they didn't do it. So why do you worry about it? You can stop it midway. Or in the initial period, stop loss. That wasn't done. My last slide now. Way forward, formulate project based on high quality feasibility study. I'm used to using the phrase feasibility study. It's DPR. Do not cut corners. Do probably 2 of them. Pick up the best. Establish value for money with private sector entity. This is doable. Project size, configuration and implementation milestones must be unambiguous and included in the concession agreement. Any departure beyond a specified limit must constitute material event of default and lead to termination. Why I'm talking of departure? Because there are always, provisions for modification changes. But when your, formulation is robust, there won't be too much of it. And even then, even if there is no change, there may be minor slippages which can be rectified. You know, you always keep, that's the whole crux of monitoring. So that should be done. Unambiguous sharing of project risks by two parties and mitigation is a must. The authority's explicit guarantee on explicit risk mitigation in its domain, probably in the RFP documents itself, will catalyze maximum competition in bidding. And authority should not be indifferent and hands-off as has been done so far. And finally, I would make a mention that the government has to have a PPP policy on what basis they would decide on going for a PPP. If you have all the money available and if you have not decided on value, and if you are giving PPP, you are sowing the seeds of failure. Thank you very much, ladies and gentlemen. I'll be happy to answer any question. Thank you very much.
Hello. Yeah, Mr. Ganatra, this Tirupur PPP project, when did it start?
We had sanctioned sometime in 1998, and then it came back again, as I told you, a couple of years later. So they started in the beginning of 2000.
No, I'm talking about the feasibility study.
Feasibility study, they were doing for about 4 years. They were working on it about 4 years.
So around 1994?
Yes.
Did you hear about the Visakhapatnam Industrial Water Supply Project ever?
I have heard of it.
Okay. So the feasibility study, that is the detailed feasibility and preparation of investment banking report. Again, IL&FS, same culprit. I was the project team leader for that. I was working for Kirloskar Consultants. Now, as most of us might be aware, this IL&FS is a company for the retired or the retiring
bureaucrats.
You said it. Okay, so hardly any technical people there.
Exactly.
And
exactly.
As a facade, they would hire foreign consultants. In this case, it was Binny Black and Veatch, collaborated with Kirloskar. We did the feasibility study and the investment banking report. I was the team leader. We completed the study, submitted the report. Similar problems like you have brought out here. Finally, a truncated project has been executed. This project was for lifting 1200 MLD from Rajmahendri and bringing to Visakhapatnam, a distance of about 260 kilometers. 60 kilometers by pressure pumping, two-stage pumping, and later by a canal starting from the Yeluru Dam, Yeluru Left Bank Canal, from there to Visakhapatnam. The project has been, as I said, executed in a truncated manner.
Same thing applies to Tirupur as well. It's truncated.
Yeah. Similar, same story, repeated. The second PPP project which I have done was for Chennai Metro Water. This is the first 100 MLD seawater reverse osmosis plant at Minju, Chennai. So I did the complete technical and financial evaluation leading to the award of the contract for international competitive bidding. Now this is also a PPP project. I'm just trying to bring out the differences between the two. This has been executed by IL&FS Befesa. IL&FS and Befesa. Yeah. So this is also a design, build, own, operate, transfer project. The cost in 2008 was about 638 crores, and the bulk water supply agreement, the cost for supply by the concessionaire to Chennai Metro Water was approximately 48 rupees per kiloliter. This project is now on rails. It has been working for the last, I think, almost 10 years now. So I just thought I will mention about the Visakhapatnam Industrial Water Supply Project because there are commonalities and ILFS is the culprit in both the cases. I think we should leave the planning of large engineering projects to engineers and not leave it to the babus or the bureaucrats. Thank you.
Just to emphasize, if policy formulation is going to, systematize the whole approach. See, as I mentioned to you, I have banked on the newspaper reports. They're supposed to have completed only 75%. Now please understand that this is water supply. Water supply cannot stop. Power plant can stop, but water supply cannot stop. So it's going on, 75% done. Some areas don't get, others get. And there are countless complaints for quality, turbidity, etc., etc., etc. So that's the problem. The amount that has been spent is in excess of the project cost which was estimated. So there have been all kinds of inefficiencies. I can only use that word. So on this basis, on basis of credible newspaper reports, I am able to conclude that it has failed. And why? What proof of pudding lies in eating? The termination notice has been issued by NMC. So now at least declare in the website that it's a failed one. Don't tom-tom it. Why? See, why it had failed? Because domain expertise was not there. See, Veolia is a great name, but nowhere we know what its contribution going to be and what was the big deal here. There was no big technology. We have in our country itself, there are about 10 water companies starting from Ion Exchange to Voltas to so many people are there, Siemens and all that. So what was the big deal? It was kind of an investor, and I can say a lot about it. I would refrain from saying that, but this was the domain expertise was lacking. Yeah.
Sir, thank you very much for touching a very interesting topic. I would like to ask why there are failure stories more than success stories?
This is a good question. See, if there are failure stories, you know how not to do things. You know, what are the factors which have led to the failure? The determinants of success are known. We have international projects. We have, even in Africa, there are some successes, right? And we have successes in CETPs, which I mentioned. Since they are successful, we'll not worry about it, right? But in water sector, PPP, where are the examples? These are this was a textbook example, you know, the kind of documentation quality, but it was all form over substance. Had it succeeded, I would have added a success story as well. We don't have success stories. And there are specific reasons for that. That's why I highlighted this. The same engineers elsewhere are going to do an amazing job. So you create an ecosystem driven by proper policy and incentive structure. You know, ISRO could do it. You could do it too. That's the simple thing. We don't have examples, to put it short.
We will wind up.
Just 1 minute. I do not know why Tirupur has failed, but on technical side, it's a very, very strong project. 80% India's hosiery export happens from Tirupur. So on business side, it was quite good. All the industries were located there, they needed water, and the purchase agreement has happened with every individual industry. Okay, so industry was supposed to purchase it from NTADCL. Now, groundwater extraction, even the situation was so bad, situation was so bad that the dissolved solids of the water which was coming from the ground was about 2200. So it was not usable. Even after that, why the industries have actually extracted that groundwater is also a question.
Okay. Good point, Dilip ji. One thing, as I said earlier, water is so crucial, and the technology and engineering involved are all open source, so it has got to be done. You can't just fail to do it. But all the loans have gone bad. Okay, so there is no point, there is no economics there. And there are some other practices which then those are out of the scope here. So that's one thing. Second, when we are doing willingness to pay study, we have to also see the economics underlying, you know. Like Kirloskar Consultant had done a study on willingness to pay study of those industries. Now everyone had an RO plant. They had only issue about disposing sludge. They could buy cheap water from there and they could continue doing it. So this should have been factored in. Even this should have been banned. That was a problem. Ultimately, you were going to give it 100 TDS water. That was a fabulous water, no doubt about it. But then it was not set up in time. It was delayed. Even before that, the High Court put a ban on them because they were, you know, the processing units were letting the water into the system without treatment. There were a lot of problems there. So, you know, ultimately, if you're doing a project, you have to do it in budget. See, when a project cost is being estimated, you're doing first in the detailed feasibility study stage or DPR stage, you are estimating the cost based on the configuration, the sizing, etc. You are leaving something for the contingency based on the, you know, configurations of certain, you know, equipment, not the main equipment which could emerge during design stage. You are doing that. You can also add something for the delay that could happen. Having done that, who stops you from achieving a timely result here? And when you have so much of relations with the government, etc. So there were other things as well. Thank you very much.
Thank you. Now this session is coming to end. Sir, now we have to wind up, please. May I request Mr. Vinayak to offer memento and flowers to our speaker, Mr. Sunil Vaidya. बाईंना प्रेझेंटेशन घ्यायचं आहे, थांब जरा. And now to Rajendra Ganantra. Now this particular session is over, and now we are quickly moving to the next session, which is like a delegate's view and comments and concluding session. So I request our chairperson Manisha Palande and Assistant Secretary General Ravina Naik to be on the dais. It will be a small panel discussion plus delegate view and then the concluding remarks, and at the end there will be vote of thanks. So I request Mr. Manoj Patil and Navi Mumbai Municipal Corporation is there. Kalbar. आता होते ना इथे तिकडे तिकडे घ्या मॅडम तुम्ही मध्ये बसा तुम्ही तिथे. अच्छा, second one is Mr. Abdul Mohammed from Odisha. So if Manoj Patil can join, he can join. So I am starting this session requesting Mr. Abdul to share the experience from Odisha.
Good afternoon to all. I am Adil Mohammad from Odisha, done MTech in Environmental Engineering from VNIT. I am the retired superintendent engineer of Odisha government. I have got opportunity to work in WATCO, the tripartite are, and also myself also doing 24/7 water supply, 2-3 zone. Today, the 2 days seminars give me immense experience that I have studied that 24/7. The tripartites are told, the policy was there. We are following 2-3 policy. One is policy, and another our dynamic CEO, PK Swami sir. His leadership also guiding us to do 24/7, and Sharat Mishra sir. Also we are using technology, that control valve, PLC for 24 water supply system. 24 hours. This also there is also one government policy there. We are doing teamwork and transparency. We are doing the work, labeling, transformation we are doing, and time limit we are following. This is the government principle. When doing any project, you have followed this T. Though that I am doing 24/7 water supply, in this conference, I was feeling that sometimes this can be done, cannot be done, but concluded that I have done and this will be done. After retirement, now I am doing OSD in IDCO, Infrastructure Development Corporation. The hockey stadium, they are international, they are studying, constructed. That Guinness Book of Record they are got, and Scotch Award also got. I have experience from this WATCO. When I coming to IDCO, I was thinking the same principle 24/7 water supply to be maintained or not. I have 20 year experience and MTech done in MTech just in service life. The water supply, because I am that senior person, when I am convincing, nobody was interested. No, WATCO, because my CEO was there, he convincing a 24/7 water supply. I was thinking how to do water supply, how to convince. After coming to these conventions, I am now confident that getting the information, I can convince all my officers that I can do 24 water supply to the workers who do the industry. The IDCO is doing the industry work. Another challenging work was to me that there is one stadium, Birsa Munda Hockey Stadium, which got Guinness Book of Records. This is constructed in 80 acre area. There is gardening there. For water supply, I was always thinking, I have not even sleeping. If you don't mind, this is true fact. So how to supply water to the area? Because in the January month, when I was at WATCO, I was felicitated by the International Hockey for supplying good water. Today, this sir told that for sub-system, we can supply the water to this. This is my dream of coming to this seminar which fulfilled. I requested every colleagues to attend the seminars. 20 years, my 20 years experience was not zero. Only 2 days is my life changing. So anybody, always I was helping, and you will attend this type of conference. Thank you.
There is one delegate, Mr. Manoj Joshi. He want to express his view. I request you to come, and 5 minutes for him.
Okay, thank you. I am Manoj Joshi, ex-Electro Steel Castings Limited, the pioneers in DI pipes. I thank IWA, especially Chairman Ma'am Manisha, and my friend and former colleague Dr. Ulhas Naik for giving me this opportunity to attend IWA. Now, in my, whatever I have learnt in these 2 days, I would say that so far in our own nation, water, though we talk about it, but it is the most precious commodity. I would call it colorless gold. I would use the term colorless gold because it's nothing, it cannot be replaced by gold even. And still, we do not assign the desired importance to this commodity, this product at all. People look at it as pani hi to hai. That is what, number one, I am against. Number two, muft pani, or what now they are using a new term, muft revdi. I'm dead against that. I say water has to be charged. You have to pay a tariff for it. You have to, and it should be taken. And as I have been told, 25 rupees per 1,000 liters, it's nothing, it is peanuts. If it is charged from the people, people are not willing to pay. But 25 rupees that they say is the charge for giving. So I feel we should, tariff revision is a must. Whether the government accepts it or not, they have to accept it. It is needed. Because otherwise, whatever good work is done by our engineers, ultimately, these financial constraints become the biggest challenge. And third, most important point is giving more authority to the water supply departments. With regard to non-revenue water is being given, it should be restricted. Fine, you give non-revenue water as a part of social justice, restrict it. 3 घंटा मिलेगा पानी, उसके आगे नहीं. So you utilize it, and we have to be strict with that. No question asked. And if no means you waste water, you are responsible. And authorization against water leakages and moreover water pilferage. On this occasion, that was not the subject, but water theft, the authority, the department should have the authority to take action. It is in the law, but it is not being implemented. They should be given the free hand. You take charge. Because electricity, theft of electricity is now punishable. Because I have seen that in UP also. Earlier it used to be that jumpers, they call katiyabazi karna, jumper se. So now they have special police cells to take action. So similar cells are needed. Either the water supply department takes action, imposes penalty, and the other law enforcing authorities take action. It is required, ma'am. It's required. It's required, gentlemen. I would emphasize on that. That's all I will say. Thank you very much once again. And that's it. Thank you.
Mr. Vadavane, please.
My name is KB Vadavane. No doubt I am Vice Chairman of IWWA Mumbai Center. But for this particular seminar, I am representing Yash Engineering Consultants. So I have come over here to give my views, to give my valedictory remarks. So the thing is, I have attended it yesterday, today also, all the sessions. So I found this particular seminar very, very focused, because up till now I have attended many 24/7 or continuous water supply seminars, but the papers, especially barring one or two, all were focused on the subjects. Design part was covered, then various success stories, especially Puri, then hands-on experience from BMC by Argade sir, and of course the most important, the financing part of it is also covered. There were 2 papers. So this was very, very successful seminar, I would say. Credit of course goes to Dr. Ullas Naik and Manisha Palande madam. They have organized it. Both are strict people, and this particular seminar also they have made it a great success. That is my views. Thank you very much. I thank all the organizers also on this occasion. Thank you very much.
Anybody want to express any view? You are most welcome. Okay. So now we move to the first greet both the ladies on the dais. One is our chairperson Manisha Palande and Ravina Naik. 1 minute. I request Mr. A.P. Nirbhavane to offer them a bouquet and memento. Ravina Naik, Joint Secretary General, Indian Water Works Association, Headquarters. She came all the way from Goa to attend this seminar. And now to our chairperson. Now I request Ravina Naik to spare few words before Valande Madam start concluding on the session.
Good evening, everyone. First of all, I would say whatever comes free is always taken for granted. So as the gentleman just now told about the tariff, recently, Goa, we revised the water tariff. The water tariff is such, I'll tell you what it is. Goa also came with a decision that per month, till 16 units, the consumer will be charged 0. We are issuing 0 bills to the consumers if they are consuming till 16 units per month. The idea behind that was to encourage consumers to use water very judiciously, because if it comes for free, it's always taken for granted, right? But what we did was, the tariff what we revised, if the consumption was going beyond 16 units, they had to be charged like as per our tariffs. So if the above 50 meter cube per month, we would charge them flat 25 rupees. So first, when our tariffs were very low, they were using water anyhow. But when they started getting good good bills, then they started doing internal audits. No one taught me water audit, but they themselves started doing, because otherwise they were getting high bills, right? And then they realized that their RCC sometimes were getting leaked, or their internal leakages were more. So they themselves came with that. And if they were going beyond 16 units, they would be charged. So they tried to keep their usage within 16 units. Also, we have started with spot billings. Spot billings is such that we are billing the consumer in front of them. So that I think Goa is the first state to do that. Also, we all know that Goa is the first state for 100% household connection to release under Jal Jeevan Mission. Also, there are always pros and cons about intermittent and continuous supply. Continuous supply, you should go 24 hours if you are taking care of leakages and your metering is proper. With this, yes. Also, we are replacing the age-old pipes with a DI and HTP. I think Penjim, we all replaced all the age-old pipes, because yesterday I think Pandit sir was saying that in Penjim there was still asbestos pipes. I would like to tell you, sir, we have all replaced the pipes with HTP pipes. Yes. I wanted to answer you, but then I said this is this. So yeah, thank you. And this is a very good program what Mumbai Center has come, because many states are doing phenomenal job, and this is the exchange of ideas. We need such platform, where people exchange their ideas. One state, what I'm saying now about the spot billing and the revised tariff, which other states might not be doing. So this is a very great platform to understand what other states are doing. Similarly, I would like to congratulate yesterday Pimpli Chinchwad. They said, because they practically did it on the site. They proved and they reduced the NRW. So that is a very phenomenal job, and everybody should, adopt their policy. So this is a very good platform, and IVA should come out with such programs in future, and we will see that all centers, this time Mumbai center did it, and I would wish other centers to come out with such programs in future. Thank you. I wish all the best to Mumbai center.
Thank you, Ravina madam. Now I request our chairperson for giving concluding remarks.
Good evening all. Now we are towards the end of this 2-day seminar. In this 2-day seminar, we witnessed presentations from all intelligent and academic minds, experts and practitioners who presented us with all the loads of information, statistics, ideas, and their hands-on experiences and examples, and also shared wealth of experience with us. And like, we have a lot of things which we can take home, and I think we need such kind of a platform wherein we can all come together, we can have the opportunity to discuss, deliberate and display various aspects, practices and technologies to improvise the way we work. So I have just tried to sum up the takeaways from today's seminar, though with respect to all the stalwarts who are here who have more than 3 decades of experience. Is it on presentation mode? Yeah, okay. Yeah. So, there was a lot of, there were presentations from 2 sides. One side presented intermittent water supply, the other side presented the hands-on experience or examples of continuous water supply system. But I would like to focus on the objective of water supply service. This is one extract from JJM operational guidelines, which is there in introduction chapter, page number 8, which says, I will just read the lines which are underlined. The program focuses on service delivery at household level, that is water supply on regular basis, regular basis, read it as adequate, regular basis, adequate quantity and of prescribed quality. So this is the objective, which says that we should supply consumers water on regular basis with adequate quantity and prescribed quality. If this is our objective, and if we have intermittent water supply and continuous water supply, now we have to judge whether we can meet this objective with these 2 modes of water supply. So what is your answer, or what would you say? Can we meet this objective with these 2 modes of water supply? I think yes. We can meet this objective with intermittent water supply as well as continuous water supply. And the answer is yes for both the modes of supply. Secondly, I have just tried to chart out or evaluate, you can say, both the modes of water supply on various parameters. First is the approach. In case of intermittent water supply, we have need or demand-based approach. Why I say need? Because in many scenarios, we cannot go for 24/7 because of inadequate source, or maybe power supply is not there for 24 hours, so we have to go for intermittent water supply. And whereas in case of continuous water supply, that is more of a supply-driven approach. You can say the authorities themselves decide that we have to give this area or this city 24/7, and that is why they design that kind of projects. Second is precondition. There is no precondition to design intermittent water supply, whereas in case of continuous water supply, we need abundant source of water, then we need power supply, good finance or good financial capacity of that local body, and secondly, good governance. Like we have seen in case of Odisha, wherein the engineers, bureaucrats, and also the politicians have come together to achieve that feat. Third is reforms. Well, like, I think there is misconception that if we have to go for 24/7, we need to carry out all the reform works, which is not the case if it is an intermittent water supply. Like, they say that to achieve 24/7, you have to go for surveying, GIS mapping, digitizing, SCADA, maybe IoT, metering, and so on. But that is not true. Even if your mode is intermittent, still you can go with these reform works and improve its technical and financial efficiency. The fourth is pumping. Like in any water supply scheme, we usually have two stages of pumping, that is from source to treatment plant and treatment plant to reservoirs. Other than that, in case of continuous water supply system, if we have to maintain pressure of 17 meters in distribution network, then we'll have to go with additional pumping or boosters. And thus, we have to keep the system pressurized, which is not the case in intermittent water supply. Peak factor. Peak factor in both the cases is 3. Like intermittent water supply, traditionally we design it with 3 peak factor, and what I have learned that even in continuous water supply, we take 3 as peak factor. Whatever I'm giving my conclusions, this I've gathered from 2 days seminar. Next is cost efficacy. If we see the cost efficacy, both are cost intensive. But in case of intermittent water supply, there is a scope for retrofitting approach, taking up retrofitting approach. But in case of 24/7, we'll have to completely refurbish the old pipe network, which is more cost intensive. Now come to storages. In case of intermittent water supply, as we always see that traditionally we have most of our households or bungalows have underground storages. But in case of continuous water supply, we try to eliminate or bypass underground storages, and then we rely on bulk storages, which can probably cater the water supply in the downtime period. Next is NRW. As we have seen from most of the presentations, in both the modes of water supply, NRW is almost 30 to 40%, or it gets reduced when we plug leakages. So it doesn't matter whether the mode is continuous or intermittent, we have to plug leakages and reduce NRW. So NRW cannot be the criteria to decide that continuous water supply system is more efficient than intermittent. And also NRW also is directly proportional to pressure and number of hours of supply, which is more in continuous water supply system. Next is illegal connections. Now, because our intermittent water supply networks or schemes are very old, so they have a lot of illegal connections, and hence it contributes to NRW. Because continuous water supply systems are relatively new, at this juncture, illegal connections are less, and probably hence they have less NRW, but we'll have to see the results in next maybe 5 to 10 years down the line. Next is contamination. Yes, I agree that in case of intermittent water supply, it is more prone to contamination, and continuous water supply is less prone to contamination. But in case of intermittent water supply, that contamination can be taken care of by doing rechlorination in the distribution network, and also by plugging leakages. Applicability. Now this is something which I think none of the speakers have touched. Like in intermittent water supply, we can use this mode of supply in all scenarios, whereas continuous water supply, or to say 24/7, this can be used in few particular scenarios wherein we have well-planned cities or townships, or those townships are planned and then the construction work is carried out. Why I say this is because if there is an unplanned growth or uncontrolled growth, or if there are a lot of uncertainties in case of growth, we cannot go for continuous water supply. Because if in a city, because we have a very good experience of Ambernath water supply water works, which is run by MJP for the last 50 years. My predecessors used to tell me that in the year 1972, that town had almost 24/7 water supply, because the growth, or they were all bungalows over there, and it was less dense, that town. But over the years, now that has become highly dense and highly populated town, and we have almost 20 stories buildings coming up there. So if this is the uncertainty, then I think no designer, because designers are not astrologers, so no designer can ever cope or accommodate this kind of uncertainty in his design. So I say that continuous water supply is possible where the city is planned. Just like yesterday we saw one example of Pimpri-Chinchwad, that all the sectors of Pimpri-Chinchwad are well planned. They first built roads, they provide electricity, they lay the sewerage and water supply lines, and then they sell the plots, and then the construction of the houses come up. So therein it is possible to achieve 24/7, and that too PCMC has good financial capacity, and again they have an abundant source of water supply. So I can always say that after Puri, probably Pimpri-Chinchwad may be able to achieve, if they do it meticulously, they will be able to achieve 24/7, maybe 3 to 5 years down the line. Last is sustainable. So I think intermittent water supply system is more sustainable than continuous water supply system. Why? Because it is to achieve continuous water supply system, it takes 3 to 5 years of painstaking efforts, but to maintain it consistently, it is very demanding than achieving it. That's why I say that intermittent water supply is more sustainable than continuous water supply, and so we should look for a solution which is more sustainable. Now there is in the first lecture by Dr. Pradeep Kalbars, he had mentioned about a vicious cycle. So here also I'm taking help of that vicious cycle in other way. We have two modes of water supply: continuous water supply and intermittent water supply. Right now we are trying to transform our intermittent water supply to continuous water supply. So this is the scenario. But maybe 5 to 10 years down the line, because of these factors, inadequate source, inadequate power supply, unplanned and uncontrolled growth, and lack of governance, it could be the other way. It could be the case that the cities which have had achieved continuous water supply, again they might get transformed, or they might transit to intermittent water supply. This could be the case. And as one of our speakers had already mentioned about the erratic rainfalls that is taking place in India, because nowadays we have high intensity rainfall, and that too erratic. It is not following any nakshatras, or we don't have average rainfall every month, but it is intensity is very high, and that is very erratic and unpredictable. So this could be the case. It may happen that because of inadequate source, that water supply, which is now in continuous water supply mode, it might again start transiting to intermittent water supply. That is why I am saying that intermittent water supply is more sustainable and something which is more feasible in Indian scenario. And these are some of the takeaways from this 2 days seminar, that no one fit solution for all scenarios, but best fit sustainable solution. Because every city, every town has different demographic characters. They have different availability of water, availability of power, then governance, the behavior of consumers, paying capacity of consumers, and resources available. So we cannot give one solution to all the cities, but we as engineers will have to give best fit sustainable solution to the cities. Next is transforming IWS to CWS is not a magic. So here I want to just convey a message to all that 24/7 is not something which can happen in a day. It requires at least 3 to 5 years of consistent, delinquent, meticulously planned efforts. Only then you can convert a city into 24/7, and Puri is one such example. But needs step-by-step, meticulously planned approach in all areas. Technical, tariff setting, policy, institutional, automation, data management, and all such areas needs meticulous planning. Next is IVS is reality, and CWS is the consequence of reform works which may be achieved in process if constraint parameters are favorable based on local condition. Here I want to imply that IWS is reality because we do design schemes with ground realities, but CWS is something which we may achieve in the process of reform works if the conditions are favorable. But that is not something we should have the objective. We should not set the objective that we have to convert the city into 24/7. But what should be the objective? That we should improve the operation and maintenance efficiency of that water supply in the city. Only then we can move towards 24/7. Next is, instead of changing design norms for peak factor or terminal pressure, why I say this is because terminal pressure is something like, as I learned from you speakers, that now CPHO says that to achieve 24/7, terminal pressure should be 18 or something, and they are thinking of increasing it to 21. So there is no end to increasing these milestones or these parameters. Instead, we should adopt or evolve design methods which better simulate ground situation, such as including shaft or manifold method. Like one of the speakers has presented this case study, wherein he showed that how shaft or manifold method can be used to have equitable distribution in the network. Or go for a composite mode, which Ulas ji also proposed. We can think of such possibilities. And the last, that to sustain CWS mode of supply is very demanding in all aspects. Sorry, there is spelling mistake because I typed it on my mobile. So like achieving CWS is very, it might seem to be an easy task, but it is not all that easy. But maintaining CWS in a city will be a Herculean task for any governance or any authority. So these are my concluding remarks for this seminar, and even for me it was very enriching and enlightening, and I hope all you participants and delegates and speakers also like this seminar, and we had very good exchange of ideas and perspectives in this seminar. Thank you.
Madam. Now we will move for the vote of thanks. We turned this idea of the making this seminar out of some discussion on IIT workshop 25 February. Okay. Thereafter, it was presented to Mumbai Central Management Committee. our chairperson Palande madam and office bearer, others and committee members vehemently supported it. So let us go for it. Then the next move was All India Institute Local Self-Government, Dr. Jairaj Pathak. He also liked the idea. He gave us such a good support, gave us this all free for 2 days. Plus he wrote DO letter to all the municipal corporation. Our next stop was DMA. Mr. Kulkarni first and thereafter Mr. Manoj Ranade. Both supported us. They also wrote letters to all the ZPs and B-Class municipal councils. And that is how we got 200 plus registration. So I first of all thank Jairaj Pathak sir, our chairperson Palande madam, Mr. Manoj Kulkarni, and of course Iowa headquarters for supporting this activity. This seminar would not have been possible with support hands of Mr. Dilip Sonane, who was like shoulder to shoulder to me for planning each and every activity, and of course Pradeep Kalbar sir for overall guidance. I also thank Mr. Lalit Sharma from Directorate of Municipal Administration, who coordinated our activity with DMA. Then Pramod Dalvi is the anchor person of Indian Water Works Association, Mumbai Center. So he was very helpful. Sunil Vaidya, Sanjeevan Pawar, Rahul Shawale, AP Nirbhavne, Anil Gadge and Vinayak Valsankar. If they would have not contributed, it will have been more painstaking for the rest. I also thanks all the speaker and the presenter who took the time out and came here and done the presentation. Yesterday was heavy raining, but our no session, I think almost everybody came and presented, and we could accommodate more as well. Of course, I thanks all the delegates who shown the interest and attended this session. While yesterday more than 100 people in the this seminar hall, and today more than 50. Parallelly, there was online streaming going on, and I think both day more than 50 delegates participated that way also. Of course, I thank Mr. Kishan Gupta for arranging the broadcasting of this seminar, and this is available on YouTube now forever. Further, we are going to make it compartmental, and presenter wise it will be organized. Plus, we are going to make a small technical compendium of this as announced by Madam in the opening session, and that will be also circulated to all the state government, all the water authorities. Of course, before I proceed further, I thank Mr. Tambe and Mr. Palekar from Iowa headquarters who supported us this activity, Mr. Vijay Lad and Chudamani who coordinated our activity at All India Institute Local Self-Government, and of course, last 2 days we had a lot of food, snacks. So I thanks Shetty and Mr. Sandeep and Mr. Khemraj from All India Institute for supported us. Thank you all. We will meet once again for the next activity. Okay. Small announcement, we organize the tea, the passing tea, one for the way. Please have it.